Oops.
So, yeah, once you log in.
Are we good?
Yeah. Check your view right now. Oh, we're going to SSH. Oh, okay. Press SSH. There's a lot of it.
All right. Good morning, everybody. Good morning. Thanks for coming in for DevOps Bootcamp Fall 2018. We're doing things a little bit differently this year by live streaming this content on YouTube. So what you see on the screen will be on YouTube as well. Hi to those that are watching on YouTube, if there's anybody yet. So I'm Lance Albertson. I'm the director of the Open Source Lab here at Oregon State University. I'm going to do the first lessons here, kind of give an overview of the program, and then I'll hand it off to some of the students that work at the lab. They're going to do a lot of the content today. If you have any questions, feel free to ask me. We're going to, at the end of the day, hopefully have an industry panel. Unfortunately, I couldn't get anybody here on site, so we're going to try a little bit of fun and get some folks in from that I know around the country and do a Hangouts live on air, and we'll see hopefully the video of them up there. One of them is a prior student from the OSL that is a Siri Apple engineer, so that's going to be some cool stuff. We'll see if I get anybody else that's going to bite. I know there's one other person that's going to be here. I haven't heard back from what his position is yet. So unfortunately, there was a couple of open source conferences this week, and everybody's getting back, and they're kind of trying to recoup from all the stuff that we're doing. So that's where we're at. All right. So an overview of what we're going to go through on this one is I'm going to go through some definitions of system administration, DevOps, and what the bootcamp is all about. Talk about who teaches it, why you should be doing it, what we're going to be doing after this event, and kind of how you can get involved thereafter. First thing about this program, we started this, I think it was about 5 years ago. So at the lab, we employ undergraduate students, but we only can hire so many students. And we saw a need on campus for students to get more experience doing DevOps-y kind of stuff. There's a lot of need out in the industry to having this kind of experience, and they really just don't teach it in the university. You just kind of have to have experience to do it. And so one of the ideas we thought we would do was kind of have an event where we would kind of go through and teach the basics of things. So this is a very introductory kind of a thing, what we're doing today, but we can dive into more deeper stuff later in the year. Some of our colleagues up at Portland State University have something called the Brain Dump, and basically they meet every week and they would just talk about some technical topic. And we're going to try to model some of what we've done here as well, but today is kind of the kickoff event. So first off, let's talk about system administration. How many of you already know what system administration is? How do you define it?
System administration is basically keeping everything running and the developers and users happy.
Yeah, keeping everything running, make all the developers happy. So that's the classic definition. So system administrators, they keep the systems running. Usually they get the code from developers, and then they have to figure out how to make it run, keep it up. They have to deal with updates of the operating system, security updates. They monitor things, they log. They look at all the logging and everything, and this is what things were like for many, many, many years in the IT industry. You know, the 1990s through the middle of the aughts, and then around that time, some things changed drastically. Probably to most of you right now, you're kind of like, why would you kind of set it up that way? But you know, it's a lot of history of how things are. There's a lot of what we call graybeards of back in that day that, you know, you don't get to do anything. And the other part of system administration is you automate as much of your work that you can throughout your infrastructure. And so in an ideal world, it only takes a small set of system administrators to handle hundreds or thousands of machines. The classic example is when you go to an interview, you want to say, hey, you know, I want to automate myself out of a job, so to speak. And there's actually been some documented cases I've read online where people have actually done that, and their managers didn't know they basically have automated their entire job. But that's the case. Like, you want to automate all the things. And you also are involved with decisions in infrastructure, how it's architected, how you have these systems set up, how it's interconnected. And also, sometimes they do get involved with QA and development. But that was kind of the old model. And then from there, we kind of transitioned into what we call systems engineers. They're basically doing the same thing, but they're creating platforms that the code run on, and they work at a lower level. So, this machine is going to be running virtual machines, and it's going to be connected this way, and the storage is going to be connected this way, the network is going to be connected this way. They have a really good understanding of how that low level of the system works and what you need to make that work. It doesn't necessarily they'll be on call, but they'll be the people responsible for all of that. They're also involved with system administrators, but it also could be just system administrators who want to have engineer in their title. So it's kind of just a lot of the titles in this industry are just kind of whatever people come up with. And then it kind of transitioned to DevOps engineers. It was a newer position. Well, it's not so new now. It's basically a mix of doing systems or operations related stuff with development work. So you pulled in people writing the code and doing system administration stuff, and it really made a lot of sense. And that's where you could get involved, where the application meets the platform and everything works cohesively. Some of the responsibilities you see is mixed. We still deal with the general infrastructure and automation. There's continuous integration, so as they work on the code, it gets integrated, it gets tested, and then the development environment workflow gets all integrated into that. They try to tie in logging as much as they have, and most of the time these types of people are on call with the application they're supporting that's also on the systems and platforms. And then from there, we've actually gotten the most newest title, and you probably have heard this term quite a bit in the industry, especially if you look for jobs, site reliability engineers, or SREs is what we like to call it. And basically, it's where things are at today. There's a lot of SRE positions that you can go out there. It basically has the same principles of what DevOps is. But SRE is kind of viewed as a specific implementation of how DevOps works with some very specific extensions of how it works. It was originally created at Google over 10 years ago as a process to kind of improve managing their services. This is actually, I think, more like 15 years ago when they were getting kind of started. They were trying to understand how they wanted to manage it, and there was a certain specific process they wanted to follow, and this is what came out of that. And now a lot of tech companies actually follow this principle. So a lot of the big companies out there all have SRE kind of positions or something related to that. Now you're probably wondering, what the heck is DevOps in general? Well, it's a field, as I mentioned, that basically takes the skill of software development and operations engineering to basically effectively create and run applications better. For a long time, there was this siloed approach, as we would call it, where the system administrators, they guarded all of the production, they would manage all of it, and it would be really hard for the developers to get the access they really wanted. And the classic example, hey, it works on my laptop, so the application's great. And then they shove it over the wall and give it to the system administrators and say, make this go. And then the system ends get all curmudgeony and just like, this isn't how it's going to work. DevOps tries to fix that. It basically tries to break down that wall, as they say. There's a couple of funny videos from actually one of the software vendors that we use called Chef, and they have a really funny video about that. And later on, we can maybe show that to you, but it really explains it really well. But DevOps defines 5 key pillars of success. The first one is reduce organizational silos. As I mentioned, you want to make sure that the application developers can deploy an app using the tools that they want in the way that they want. And also the system administrators can make sure that that service always stays up, because that's where we're at in this age. You want to make sure everything is up and working. The other part is accept failure as a normal. Things break. Things happen. We don't place blame on other people. We place blame on, or we don't really place blame. We just say something is wrong. We need to fix it. Why did this happen? How do we prevent that from happening in the future? You've probably encountered this over the past couple of years as large problems have happened throughout the cloud. I know like AWS S3 went down about a year or so ago, and it was a huge deal. And ironically, the AWS status page was hosted on an S3, and it wouldn't update because S3 was down. But there was some kind of a failure that happened, and a lot of these things are built into that. Netflix is a great example of that. They expect failure to happen. They actually have a software tool called Chaos Monkey, and they basically run it every once in a while to make sure that their infrastructure can randomly go down however it wants, and it magically comes up and works better. So that's kind of where they're at. Implement gradual changes. That's really key and important in DevOps. You don't want to push out a big change, because then it takes a lot to make sure that, hey, did I forget something? Is this working? It makes it really easy to implement these changes incrementally as you go through. And also leverage as much tooling and automation as you can. I can't keep up with all the tools and automation processes that are out there. And that's my job, is I want to teach these students that I have at the lab all these various tools, but it's hard to keep up with it, and a lot of it is so bleeding edge, it's hard to do that, but that's an important part, is to leverage all that tooling that you can to make your life easier as much as you can. And the last one is measure everything. And this can get a little hard, because you have to understand, what do I need to measure? What makes sense? You know, if you're at a company, you're probably measuring output of how much money you're making. Well, what does that really mean? Or if you're in an application, you're probably interested in response times, things going down. You know, you want to be able to see if something changes in how things normally work. You know, another classic example is we have a disk check on a system. What we always get is the classic, hey, I'm out of space in the middle of the night. But really what I want is, hey, this change of rate happened, and suddenly I'm seeing an exponential growth of disk space change, and something is definitely changed, and I need to know about it. So you need to measure that and also monitor it. Any questions so far? Okay. All right, so what is DevOps Bootcamp? It's a couch to DevOps in one school year. It's a free educational thing that we want to do at the Open Source Lab. We are your mentors, and we try to help you with the related tools that we're experienced with and getting you involved in that. It's a challenge for any of you to kind of get into this. There's a lot of new terminology and a lot of new tools, but you know, it's exciting. We try to make this as one-on-one as we can today. Obviously, we're doing it kind of a lecture style, but we're going to do something a little different this year, hopefully, to kind of work around that. And we're going to do a lot more hands-on training as much as we can. There's going to be some of it today, but it'll be much more of it throughout the year. And all of the course materials is free and open on the internet. We have this on a GitHub organization. You can see this. If you find any typos or errors, you can make a pull request and make changes if you want. So what is this not? Well, it's not a 4-credit class, as you obviously know. We don't pay you. We wish you could. And you know, as we move forward, it's not going to be entirely easy, but it's going to be fun. It's definitely going to be fun. What I'm trying to create with this is kind of the experience I had when I was a student back in the day, way back in the day, where I had a help desk job, and my boss at the time, he was really big in Linux, and when we had downtime between things, we kind of had a little lab there where we would play around with stuff, and that's kind of what I'm recreate, because it's really fun to actually see how some of this stuff works, and like play around with it in an environment where things can break, and you can see how it breaks. So that's what we're going to try and replicate. Over 5 years ago, the Open Source Lab merged into the School of ECS. We used to be under Information Services for many, many years. So now we're under an academic unit. We're also trying to meet the company demands. A lot of the vendors and companies that support us financially are really interested in the students that come out of the lab. A lot of the students that have come out of the lab have moved into very interesting positions throughout life, some of which have created startups, sold them, created second startups, sold them, and so forth. So it's lots of cool stuff in the industry. And we're trying to also bridge that skills gap that happens with all the curriculum, because you learn all the theory and how everything works in school, but what you really need to know is, hey, how do I actually apply this to a way and a job that people will hire me and I can do something that I enjoy. We also wanted to build like an active DevOps learner community here on campus, which is really important. So what you will do, you will learn about Linux systems, you will learn some basics about networking, software development, and tools that we use and why they matter. And we'll also build some applications in the cloud and talk about cloud infrastructure as well. I don't know if we'll get to that today, but we will eventually throughout the year. So as I've mentioned, I'm one of the people that help teaches it. Also, the OSL students, can all of those stand up and wave, hey, I'm an OSL student? So we got one here, got one here, got one here, got two in the back over here. So they're here to help you throughout the day. If there's any issues that come up and you have some questions, they can help you with that. and also guests from the industry. So hopefully throughout the year we'll be able to have either virtually or in person some folks come in. There's lots of people up in the Portland area that I know that can give some really interesting discussions and so forth. So, and you, obviously, you can help each other. And that's really what happens at the lab. The students help each other as they go through things. So something new we're going to do this year is something called the biweekly open office labs. So in years past, what we tried to do is we tried to do a lecture thing every week, every other week, or every other month or something, and that just didn't bode well for that environment we wanted to create. So what we're going to do is we're going to create an environment. We're starting actually next week. We're going to open up the offices where the open source lab is, and we have 2 time slots available. We have one on Wednesday morning from 10 a.m. to 12 p.m., and then one on Thursday afternoon from 2 to 4 p.m. Pick one of those times. Hopefully it works for each of you. I think we have a survey or something out, or we have a Google form that we'll get a link to you about that out in case that doesn't work and we can have some individual things. But what's going to happen is that experience I told you about where you're going to have some hands-on experience with stuff. So, we'll probably start out with some of the additional topics we already have on the website and go through that. But it just kind of depends on who shows up and what we want to learn. We can learn about how you automate installing Linux. We actually have a small little data center right there in the office. It's not our main one, but we have some cool stuff in there. Like through some of our relationships, we actually have 3 racks of open compute hardware from Facebook. This is the hardware that Facebook runs in their data center. It may be a little bit outdated from what they currently run, but it's really cool. It's really interesting. You can actually, like the BIOS chip comes right out. It's not soldered in. You can put on LiberBoot or whatever you want. Lots of cool stuff. We also have some spare hardware that is out of production, and you can get some hands-on exposure like how this works. A lot of things these years, a lot of DevOps engineers never deal with the physical hardware because you're dealing with the cloud. So we'll give you that experience. Also dealing with things like, hey, how do I manage a server without actually being physically next to it, dealing with out-of-band. Installing servers if you want to see how that works. Setting up various services, I should say. So if you want to set up an email server, a web server, DNS. Also, we can have you helping with some open source contributions of various things if there's a project you're passionate about. And then we'll also dive into some software development throughout the year. So we don't really have a set structured format for how we're going to do it. It's going to be an experiment. We're going to do it every other week, at least this term, and then the following term we'll probably do that as well, depending on our schedule. We're doing it during a time slot where most of our students are going to be in the lab and we can be there and help you. Be prepared to bring your laptop. We do have some computers there, but it's probably best to have your laptop there so we can have you work through there. We have limited space, so we'll see how this kind of works. But we want it to be, interesting to you. What do you want to learn about? Maybe we'll take small groups and kind of figure that out. We could also give you a tour of the main data center of how things work at a larger scale. So put that on there and look into that. So the agreement, if we come up, what you get what you put in. It's free education. You get hands-on experience. Show up if you can. If you can't, try and do what you can. Go through the content after this course, and then if you have questions, come into one of the biweekly meetups, and we can see what we can do. Give us feedback. We want to improve this as much as we can. We've done this over the couple of years, and each year we try something a little bit different to try to make it a little bit better. And also get involved. We do have a Slack channel. If you have an OSU email address, you should be able to access it. If you don't, let us know. We'll get you on there. It's pretty quiet right now, but maybe we'll get more active as we go through this year. Feel free to kind of ping folks on there during this course of today. We'll be watching that as well. Ask questions. We don't expect you to know all this stuff. There's going to be lots of terms you have probably never heard of before, and that's great. And just be fun, be calm, have fun, and just go forth and through that. Any questions before I move on to the first steps? All right. Hopefully this link works. Hooray. All right. So now we're going to go through the first steps. We're going to learn about some basic vocabulary about Linux, the notation you'll see on these slides. We'll set up the initial student development environments that we have with those slips. So if you haven't gotten one of those slips up front next to JJ, you can get up there. That'll log you in to the environment we have and have fun. And hopefully we won't have any technical difficulties today. Knock on wood. So some of the general topics, software obviously is the program that runs on a computer. Operating system, that is the software that manages the other software. It takes control of the hardware and it manages the virtual memory, the CPU, and so forth. GNU Linux, or Linux if you want to call it, is the free and open source operating system. Linux is the kernel that runs, and then GNU has a bunch of the software, the core software that runs on top of it for a lot of the basic commands that you do. Computer security, that can deal with anything from physical security to soft security, like software, like with software and so forth. Virtual machine, it's a computer emulated in software. So we won't be dealing with that today, but we'll go through if you want to run it on your laptops eventually. It takes a little bit more work, but a lot of the world uses virtual machines. It's like you have one computer and you can run tens of thousands, or not tens of hundreds maybe of VMs on one machine, so you can carve out that the capability of that physical hardware. That's when you hear about the cloud, that's basically what's happening. EC2 is basically a virtual machine delivery system where you can spin up virtual machines on somebody else's hardware. Containers, they're not virtual machines, but they're basically kind of like virtual machines. If any of you have ever heard of a CH root in the old world of Linux, it's basically that with fancy networking and namespace things. But basically it's a way of creating what looks like a separate system inside of another system without virtualizing all the hardware. There's another part of the kernel that can kind of do all of that. And that's what we're going to be utilizing today. You're going to be logging into a container on a system. You're actually going to be logging into a container on a virtual machine that's running on a physical machine sitting in Kerr. And as all things with this industry, that's layers upon layers upon layers. It's fun. On the development, we're going to deal with version control. Hopefully all of you are already familiar with Git and GitLab and GitHub, but we can definitely help with you. We'll talk about that more. Continuous integration is really an important part of what we do. We won't be doing it a lot today, but that basically means is you go through, you make a pull request with a small change, as I mentioned earlier. It gets reviewed, it has some unit tests that run, maybe some integration tests to make sure it works, and then it gets merged in, and hopefully it gets actually deployed eventually into production. That's how a lot of these big websites like Facebook and YouTube and whatever else out there, they do that the same way. They have small iterated changes that happen throughout the day to get pushed out. Some other buzzwords: FOSS, free and liberty open source software, also known as FLOSS, if you want to go with that. Free as in speech, not free as in pizza. It can be both. For today, it's going to be both because you're getting free pizza, so there you go. But a lot of the software, we try to use as much software as we can that's free and open source. I won't go through the specifics of the differences between that. There's some people in the industry, they're very picky about that. But that's really important with what we do at the Open Source Lab. The cloud, basically, computer is somewhere else, and a big data center somewhere else. And then Docker is software that manages Linux containers. That's one of the many different kinds of software that's out there. So what kind of vocabulary do you know? Can you think of other vocabulary that's related to DevOps that aren't OSL students? Okay, OSL students, give me one. Huh?
It's hard for them.
Yeah, I put them on the spot.
Super users?
Huh?
Super users? Yeah, but
Super user? Yeah.
load balance?
Load balance? Yeah. So what about Silicon Valley programming? Yeah, there's some of that, yeah. We'll go into that a little bit more, but basically it's a way of balancing the load between multiple servers. So an idea of like you can have two servers serving the same application at the same time. One of them can go down and you have a load balancer in front of it that knows one of them's up, one of them's up. All the traffic goes through the load balancer, and if one goes down, it stops sending it there. And from the user point of view, it's being balanced to the other one. So that's keeping uptime, but it also can be, hey, this is such a heavily loaded application, I need to have many, many servers to keep up with the load. So that's one way to kind of describe that.
And what's a super user?
Super user is the root user of the system. So it has all permissions for all the things on the system. I think that covers about a lot of that. What that is. There's tons more out there. as you see through these slides, you'll see a lot of notations. So here's what it might look like. So here's what a variable looks like, notation for variables. Sometimes we kind of use a wave like that. We have a literal, so here's what it might look like. Comments, it can be a variety of ways of kind of putting comments in there. So a lot of that you should already know about. Here's a code block, just kind of what it looks like. Here's a Python code block. Nice thing about our slides, we can tell what our programming language is, so hopefully shows up here pretty easy to see what you want to do. We'll also show like what things look like on the terminal. So, trick question, how might you read this? Programming example. This is Python.
You're printing dogs, you're printing those variables.
Okay, but what is it actually going to print?
Breed 1, breed 2, breed 3 with the dollar signs in front.
Yes. Yeah.
So is DevOps a language or is it a concept that you're using other languages with? Like, will we be using Python today or?
It's DevOps. It's one of those funny meta terms
Okay.
that's out there. Nobody can actually define what DevOps is exactly. We just know what it's kind of about. So it's more about the principles of what you're doing. You're following principles of development and system administration works together. You're iteratively putting code out. It's just a process of how all this kind of works. It's also kind of a buzzword, what people use. But basically, it's what, in the modern day, what you do when you go to work for someone like Facebook or Google. You do DevOps-y kind of things, whether it's being a site reliability engineer or whatever there is. You know, a lot of times it means you're writing code, but you're also in charge of making sure that code runs on whatever platform your company is using, which is probably a container-based kind of system. So you need to understand the full breadth of everything. Just not writing code is kind of what it means. It's like you know a little bit about systems, you know a little bit about development, and you work together on that.
When we do start doing little projects today, will we be using Python?
I don't remember if we're going to get to Python or not.
There is a somewhere way later on, and I don't think we're covering it today, but you set up a Flask server, but that's like less than 20.
Yeah, but we can get to that. We'll probably get to that in the bi-weekly meetups and go through that. If you're interested, we can maybe even do that in the first one.
My question is because I don't know Python yet.
Oh, yeah.
So
And we'll help you with that. Yeah, I mean, there's a lot of Python is very easy to read. That's one of the nice things about Python.
Depends what you're doing.
Huh?
It depends what you're doing. You can make Python completely empty.
Well, yeah, you can do that with any language. Perl is a good example of.
Yeah.
It can. Yeah, that's yeah. But Python is, I feel, is easier to read. We use a lot of Ruby at the lab for a lot of the tools that we use, but it all kind of intermixes quite a bit. Another one, we can replace breed in with an actual dog breed. So what do you think this actually prints? Yeah. Yep. So this is an array in Python, and then we're cycling through that and printing what that actually is. Okay, so the most important tool for a DevOps engineer is SSH, Secure Shell. It provides a secure way of connecting to a system and having a remote command line interface to the system. I already mentioned that. From way back in the day, it replaces a tool called Telnet, and a lot of things still use Telnet, which is basically a completely unsecure protocol. It wraps security around it quite a bit. It allows for password logins and also private public key-based logins, which are more secure. Today we're just using password logins because we don't want to deal with the hassle of creating SSH keys and putting them on there. But by default, what we usually do is we disable password logins, and you have to have an SSH key to log in. There's other various forms of methods that you can log in and authenticate with SSH, but those are the very basic and most common things you can use. You can do some really interesting things with SSH. You can run just a single command remotely on a system if you want to. You can copy a file securely between a system. You can also do port forwarding, which is very useful if you're trying to connect to an application that's only listening to localhost. You can SSH to that, forward port that port from your workstation to there, and you basically can connect securely through that SSH tunnel. You can also have what they call the poor man's VPN. You can set up a SOCKS proxy with an SSH tunnel. And so you can give it a command, it opens a port on your local system, and then you can tell your Firefox or Chrome, connect to the SOCKS port, and it'll cycle through that to send all the information through there. People have actually made user space file systems out of SSH called SSHFS. So yeah, SSH is very, very, very versatile. Setting up and using Linux, there's a lot of ways to run Linux. The classic old school way is dual booting Windows and Linux. You want to be very careful when you do that. I haven't done it in many years because I've run Linux as my primary OS, but I'm sure some of the folks from the LUG, the Linux users group, can help you with that at some point. But that's certainly one way you can do it. The easier way is running a virtual machine. There's various tools and software you can use. VMware, which I don't remember if OSU has an account for that or not. VirtualBox is free. That's the one we use the most. And you can also just get a cloud server from one of the providers. If you have an account and you want to spend money or use a free tier one, you can do that. You can run Docker container directly on your laptop if you want to. That contains Linux. It's not like a full running operating system, but at least gives you the same tools and everything. And that's actually what we're going to use today. It's the easiest way for us to get you guys set up with having to have you go through and install VirtualBox, make sure your BIOS settings are right, and blah, 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 blah. We can help you with that later, but today we wanted to make it simple. If you're running Windows, they have a Linux subsystem now with Windows 10 that you can use. I haven't experienced it, but I'm sure some folks in here used it. But there's that as well. So as I mentioned, what we're using today, we're going to be using a virtual machine that has Docker running, and it has, I think, 100 containers running on it. Each of these containers is running an operating system called CentOS. It is a free version of Red Hat Enterprise Linux, which is a distribution of Linux, and we'll go through that, I think, today or at some point. We use CentOS at the lab. It's just one of the various, one of the distributions out there. Debian, Ubuntu is another one. Fedora is like the latest and greatest of what CentOS might become. You're going to SSH to the containers remotely. The way we have the firewall set up is you need to be connected on OSU's Wi-Fi network or on the network somewhere on campus to connect to it. Otherwise, it'll time out. Depending on what we do, we might remove the servers within a week, but at least gives you some access on this. Hopefully, you can get things set up on your laptop and do what you need to do. If you want to do some other things later on today, we have some guides on how to set up Docker on your laptop or a virtual machine if you want to do that. So let's actually do something. So the first thing, you got your login credentials from us. That has a port and a password. So what you want to do is you want to open up a terminal, or if you're using PuTTY, open up PuTTY, and then SSH directly into the to this URL. It's the same user for everybody. You just have a different port and a password. So it starts out with a port number, and then it has a password, which is what you use to type in there.
And if you need help, just raise your hand. We'll
Yeah.
be looking at it.
So let me switch over on mine really quick, and then I'll switch back to this. So you should log in and should be in a container at this point, something like this. So I'll go back over here. The port number should all start with 330.
Okay, I got host key verification.
You might need to reset that. Have you been to this before?
No. No, but I'm ready for the phone.
So that's the host name is it's pretty defined by the DNS, especially in this case. So we like file that host name. It's not using say that opens the specific IP. So that IP is mapped to the
If you have PuTTY installed, You can connect using it this way. And if you go on the DevOps Bootcamp.OSUOSL.org, all of these slides are in an HTML form, and you can go to those links and go through that quite a bit more too. So DoBC is the user, and then the host name is dobc-shell.OSUOSL.org.
Yeah, DoBC-shell.
Oh, you're connected. Oh, okay. Well, if you disconnect from that, we can.
You might put that up on the board too.
Yeah. Well, a lot of people use putty too, so.
I know, I was going to leave the putty one up, because that should just be...
Raise your hand. No, I was just resting my hand. Sorry. Yeah. That's most of the things. Yeah. I think you can. Yeah, you can do things like it, but we have some stuff already set up. I feel this kind of stuff.
Basically, if you're doing it somewhere else, you might need to install packages in the container now.
So let's try DoBC.
Look at it later.
So like install packages would be. Basically, that just verifies that you're. So we also have an online website page that has ways to define assets.
Yeah, let me show you really quick.
So I'm just going to open up the actual website. Because besides the web page and stuff.
So,
That's what the web page looks like. Yeah, see, they got. No, that's cool.
oh, Jason, she's needing some help back there.
Yeah, and also these tools here aren't gonna zero. But the setting up a virtual machine might be, well, what are you running on here? Like, what operating system?
Well, it's Mac, so.
Okay. The easiest way to do it, probably to set up a virtual machine. Because what a virtual machine does is just creates a literal virtual computer, and then you can install Linux to that. CentOS has a installer that goes through everything for you almost automatically. You have to like say a few things, but it
Yeah.
should be pretty straightforward.
After we get into, after we confirm everybody logs in, I have a couple more slides about what you can do after the fact. But we have it all up on the website as well, so.
Oh, here. I'll give you this one.
If you wait 2 seconds. install Docker. So, I mean, you can install Docker if you want, but
Yeah, if you want to install Docker, you can, but the way we have it set up, we're already doing that for you, so all you have to do is SSH to a Docker container.
and the easier because you have a lot of stuff pre-installed.
I'll talk about more about how you can set this up on your laptop after the fact, but we want to avoid that today because we would spend like 2 hours getting everybody working. And that's what the open office hours are kind of for too. We can help you get that kind of set up as well. But yeah, the easiest thing is to log into this container. Who hasn't logged into their container yet? Oh, you just got here, yeah. Yep.
I'll catch up.
Yep. Raise your hand if you need any help logging in.
Alright, so I don't think you need to use your
Oh, PG. I did over the summer. I was in a VCOP internship there. So maybe not. Yeah. Well, actually, it goes for VCOP in June. Not. But yeah, this is like a VCOP. There's a PG shirt. I got it when I was there. My OSL shirt is dirty, so it's a nice little thing.
Okay, let's try honey instead of upside down. That'll work better. I mean, where you
Is the YouTube, is it streaming and you'll be able to look at it later?
Yeah, yep, it's streaming right now, and then it'll be archived later. It'll be on the OSUOSL YouTube channel.
How are you recording? Where is it? Oh, okay.
Yeah, we have this laptop set up with software to do that. JJ got that all set up. He's awesome. We're using a software called OBS Studio, which is it's open source, I think. Yep. And then we just set up an API key for YouTube, and we can have it go.
There's not really any like.
So far, stream looks good. You can hear everything too.
Like
Yep.
verbs or adjectives on the ends.
We're live on the interwebs.
Alright, so open it. So it should be installed.
I didn't know about it until they told me about it. I was like, why didn't we have this years ago?
Yeah, just a basic RTMP streamer, and
Mhm.
then you just send it to the right URL, and then you can broadcast everybody.
Yep, yep.
You can use Nginx servers to act as a host if you have like one with a bunch of bandwidth. Then you can use that instead of using YouTube.
Oh, cool.
And it relays it to everybody.
That's cool. That's cool. All right, I think
Yeah, sometimes.
we'll going. We'll continue on here in just a couple more minutes. Make sure everybody was able to log in. And also, don't forget we have coffee in the other room if you need any, or hot tea or water.
So it's saying like they've never connected before. You try.
Huh?
And this
First time connecting, yeah.
Yep.
Okay, so the username, which is DoBC. Password is blank paper. It doesn't.
All right, well, I'm going to go ahead and move on. I don't think we're going to have you guys do anything quite hands-on in the containers quite yet, but I want to at least make sure most people are in there. As I mentioned before, after today, we recommend that you install Docker on your laptop or your computer. and also install Docker Compose. If you go to the website, you can find all these links and go through that. Docker Compose is a nice little tool that lets you orchestrate multiple containers to do things together. It's a safe way to kind of sandbox things. So a classic one that we have set up is we have a database server running in one container, and then you have a web server running in another container. And Docker makes it really easy to connect the two up so that they know how to talk to each other. So we have that. It's going to be the same basic setup that we have set up here, except it's done a little differently. Make sure you read the installation documentation on the Docker website and what you need to do, and if there's any BIOS settings that you need to change. I don't know how that is these days. Usually it just works. So, and it should work on Windows, Mac, and Linux, obviously. I know it works on Linux, but it's used around the world, so I know it works really well. And you can come to our open office next week, and we can help you get that going if you have any trouble with that. Once you get it up and going, you can start a container by doing this. You can clone this repository that we have on GitHub. You can also download the tarball if you don't have Git installed on your system and do it that way. And once you go into the directory, you can run the Docker Compose command. That command starts up the Docker container, the two Docker containers, and then you run the second command to open up port 8080 on your system so you can connect to it from a web browser. And then it puts you into a bash shell into that container so you can interact with it. And then you can just exit out of that container by typing exit. And then you can remove all of the containers using those commands as well. And all of this is on the website as well. Feel free to try other Docker images. I don't think we have Docker files that set up with that, but you can do it pretty easy using this command here. You can see what it's like running Ubuntu, Debian, Fedora, CentOS.
How do we access these slides you got?
If you go on DevOps Bootcamp.OSUOSL.org, if you go, let's see, we'll go here. This is the front page. All of these lessons are here. These are the mirror image. So if you go to first steps and you see up here it says slides, that will take you to the same thing. Or if you look at just the page, it probably has a little bit extra content that we show that we don't want to shove all into the slides. So. But yeah, take a look at the Docker Hub. There's things out there for all the things you can think of. And do what you want to do. If you want to actually deal with an actual operating system level of this with a virtual machine, you can use a variety of tools. The one that I recommend the most is called, the tool that I recommend you use is Vagrant, and then the actual hypervisor that actually creates the virtual machines, I recommend VirtualBox or VMware. I use VirtualBox quite a bit. It's free and it's open. Vagrant is basically a tool that interacts with any of those kind of hypervisors. It has a file called the Vagrant file that defines how you create a VM, and it makes it really easy for you just to, I can't remember the next slide, yeah. It makes it really easy to just start things up. So for example, we have a Vagrant repository that has various operating systems on it, and all you do is you go into that main folder, you say Vagrant up, and that creates the virtual machine, starts it up, boots it up, and then you just type Vagrant SSH, and it'll log you into that VM that's running on your system. I have several other operating systems included in there if you want to play around with them. I think I have Ubuntu and Debian in there as well. Just go into that directory where the Vagrant file is, and you can type Vagrant up and kind of look into that. But that's another cool way of actually seeing what it looks like. You can open up the console on the virtual machine as well and kind of see what happens when it boots up and have fun. The nice thing about that environment is you can mess it up all you want, and you can do Vagrant destroy and start it up and it's all fresh and new and you won't destroy your laptop. So it's fun to kind of see how you can break or fix and deal with things internally with Linux without worrying about completely blowing away the system. There's also the Windows Subsystem for Linux, which I mentioned before. I haven't used it myself, but I'm sure you can get that going, and it works in a similar way as a virtual machine. All right, so the next step that we need you to do is change your password on your machine. So you need to know the password you already have, and then you just type this command, passwd, short for password, and then you just type in, first you put in the password that you have, and then you put in a new password.
You talking this password or?
Yeah, so you type in first this password and then change it to something else that you know. And whenever you log in next time with SSH, that will be the new password. And if for whatever reason you mess up your container and you can't log in, let us know. We can easily recreate your container and get that going fresh again. I'll go ahead and do that on mine. And OSLers, we're using our default password for what I changed this to. They know what that is. And I will double check that it works, so I can log out, log back in, and hopefully I typed it correctly. Yeah, there we go. I thought I typed it wrong that one time, so. Whoops, there we go.
It happens a lot when you're actually secure things.
Yeah.
We're not perfect, computers are more perfect.
Yeah, exactly. Well, I don't know about that.
Well, sometimes. Systems. Well, even that.
All right, we'll continue on to the next one. So there's more information you can kind of go on our website and learn about. So if you need a doc on how to install these various things, they're right there. So with that, we're moving on to the next one, operating systems, and I can't remember who's doing that one. Jason is? All right. So I will hand this over to Jason. And if you have any issues changing your password, logging in, let us know.
Hi, I'm Jason, and I'm going to be talking about operating systems. If you've taken CS344, or especially if you've taken 3 or 444, a lot of this material is going to be it's going to be something you've already been exposed to. So don't kill me if I get something wrong, because I'm in 344 right now. So we're going to give a high-level overview of what an operating system is. So we'll take a look at some general parts of an operating system that are common to many of the general purpose systems that we use today. So Android, Linux, Mac OS, Windows. And then we're going to discuss some of the families of operating systems. So Unix has many different operating systems, including Linux and Mac OS, FreeBSD. So we're going to talk about some of the differences between those. And then finally, we're going to end by talking specifically about distributions of Linux, because that's what we use at the OSL, and also it's what's used in a lot of servers and data centers. So at a high level, an operating system is software that sits between your hardware and the applications that run on your computer. And it provides an interface to that hardware, because a lot of the details of the hardware we don't want to have to mess with. So the operating system abstracts all that for us. So for example, if you're writing a program that creates a file and then writes some data to it, especially even in a language like C, which is relatively low level, you don't know how the operating system is doing that. All you're knowing is that you're creating a file and that you're writing to it. You don't know where the operating system writes it physically. You don't know how it does it, and you don't know how it actually creates the file either. So at the end of, as we're going to talk about in the next slide, the OS actually the general purpose systems we use actually manage all of our hardware, and it only provides our running processes the access that they need. So a running process can't actually access the hardware themselves. They have to go through the operating system, and there are good reasons for that. So here are a few general parts of the operating systems that we see today. So the user interface is what you use to actually interact with the OS. On operating systems like Windows or Mac OS, this is usually graphical. So you have a cursor and you're moving it around on the screen. You're moving windows around. But you also have on Linux these. You can also access a shell through a command line interface, and these are textual interfaces. So there's no fancy cursor. There's no There's no windows to drag around. It's solely a cursor on a terminal, and you're typing in and you're seeing text go through. So we're going to learn more about the shell in a later lesson today, but just know that that's what you're typing into when you use a terminal. So then the application layer is where your user programs like web browsers and text editors run, and these applications don't actually have access to the hardware. Instead, what they do when they need to access the hardware is they go through the operating system. So going back to the example of writing a file, an application itself doesn't write a file. It asks the operating system to do that. And it does that using pieces of code, libraries that are specific to that operating system. And those libraries provide what are called system calls. So you use system calls to communicate with the operating system and ask it to do things. So then you have the kernel, and the kernel is what you might call the core of the operating system, and it's actually the program in the operating system that manages communication between the hardware. It provides the interface over the hardware. So one of the things it does, since it has full control over your memory, is when you launch a program, it allocates memory for that program, and as a part of that, it's also responsible for security because it allocates memory to programs. It needs to be able to isolate programs. So it keeps programs from accessing each other's memories, and which is an important part of security because you don't want a malicious program that's running on your computer to be able to read some sensitive data that's stored in another program. The kernel also provides an interface to input-output devices, so it makes things like your storage devices work, your keyboards, your mouses. That's how applications are able to receive that input. The kernel handles all that communication for you, and provides a nice interface, so you don't actually really need to understand how the hardware is working at a low level. And in multitasking operating systems, which we're going to talk about, so if you're running multiple programs on a computer at once, your CPU isn't actually running all those programs simultaneously. Instead, typically a single core of a CPU can only run one instruction at a time, so the kernel is also responsible for scheduling time for processes on the CPU. So it gives a little time to one process, then stops that process, gives more time to another process, stops that process, and it's this cycle that makes the program run, that makes the programs run, but because the CPU is so fast, you don't really notice that switching between processes in each core. So it does some really important things, and now we have to make a distinction between two types of kernels. So we have microkernels and monolithic kernels. And microkernels are just, it provides a bare minimal interface to the hardware. So it doesn't provide things like device drivers. It doesn't provide things like device drivers and file systems, and those are actually in the application layer if you have a microkernel. But if you have a monolithic kernel, which is what Linux is, those drivers, those file systems, and other software are all embedded in the kernel, hence the monolithic kernel. Microkernels, the benefit of those might be that they're easier to maintain, that they're smaller, so they might just be a bit easier to understand. So all of this means that the kernel and the operating system provide a really important interface to the hardware. We don't want to have to, as programmers, we probably don't want to have to know how to write a file to a specific location on a disk. The operating system handles all of that for us. And then we have the actual hardware. So this is what actually does the computations. It stores your data. This would be your SSDs, your monitors, your graphics cards, all the components in your physical system. And these are a few different types of operating systems. These are not disjoint, so you can have operating systems that have more than one of these characteristics. And so a single multitasking operating system, we talked about a multitasking operating system back when we were talking about kernels. A multitasking system can run multiple processes at once. So you can open up a text editor and your web browser. You don't have to just be in your web browser. Whereas a single tasking program, I don't actually know any examples of this, but this would be an operating system that could only run a single process at a time. So then we have multi-user operating systems. Most of the general purpose operating systems that you know today, so Windows, Mac OS, Linux, they're multi-user operating systems, which mean that multiple users can access the system at the same time. So right now you guys are all on DoBC shell, you're all logged into the same server, just on containers on that server. So Linux is a multi-user operating system, Mac OS is a multi-user operating system, and then single-user operating systems, as you might guess, is when you can only have a single user accessing the system at once. And you might consider something like iOS, yeah.
So I have a question. So why are there different ports then? If we can all log in at the same time, then why are there different ports that are created for each user?
So that's because of the way containers are set up. Because you're given an entire container to yourself, we have to launch the SSH daemons on each container individually instead of like one big one that you can log into. And because they're each different daemons, they all have to take their own port, and therefore we have to get an entire array of ports out.
Yeah, this is instead of deploying 100 different virtual machines that all run on port 22, we just have one virtual machine and we just assign a different port for each one.
Yeah, so you can think of, you're not connecting directly to the machine, you're connecting to a container on the machine, so it's like you're connecting to a different machine. If we were all connecting to the DoBC shell VM directly, we could all go on port 22.
Thank you. Well, it's not as safe.
So then we have embedded operating systems. Embedded operating systems are the operating systems of embedded systems, if that makes any sense. So an embedded system is a computer. It's computer hardware that's embedded in some larger device. So this might be a car. This might be a smart appliance. There are some computers in there that do very specific things. So embedded operating systems tend to be very lightweight and not very performance heavy because they run on generally less powerful hardware and they consume less power. And then
Embedded are actual hardware pieces, or it's software?
so the embedded operating system is the software, and then an embedded system is what is like a piece of computer hardware that's small that's embedded inside another system. Or not, it doesn't, I don't think it has to be small, but it's just some system that's embedded in some larger system.
For example, like a Chromecast is a really small device that has an embedded operating system in it.
It's much more specialized.
Yeah, it's more specialized.
I think
or any of the IoT devices out there in the world are running on some kind of embedded.
I think the example that was given in the EC375 class is like an anti-lock braking system in your car. So there's a specific computer chip in there that monitors your brakes. Yeah. So then real-time operating systems can also be embedded, and they solve a very specific problem. Real-time operating systems are needed for time-critical tasks. So I mentioned earlier that if you have a multitasking operating system, the kernel schedules tasks, and you don't really know when it's going to run and for how long it's going to run. So a real-time operating system can guarantee that a specific task will run at a specific time for a given amount of time, and this is really important if you need a guarantee that a task can run for a certain amount of time.
An example of where that's important is aeronautics and space. So for example, SpaceX uses Linux, real-time Linux, on their systems going up in space. They want to make sure that things fire off or turn off at exact times.
Yeah, and also I know a lot of avionics use real-time operating systems. You don't want your plane's avionics to hang on because somebody's playing some game. So we're going to talk about a few different operating systems. So we're mainly focusing on Unix systems because that's what we use at the OSL, and that's what dominates server usage around the world. And so this includes some distributions of Linux. If you didn't know, Android is a Linux distribution. We're going to talk about Debian and RHEL. We use the free version of RHEL called CentOS at the OSL. Mac OS is also a Unix system, if you didn't know that. Mac OS and FreeBSD are derivatives of the Berkeley software distribution, which is another type of Unix, like Linux is. So then you have Windows. Mac OS and Windows are unique here because they're not free. So Linux, FreeBSD, The distributions of Linux and FreeBSD are technically free and open source. Mac OS and Windows, they're commercial software that you have to pay for. And actually, because Mac OS is a Unix-like operating system, a lot of the utilities you get on Linux actually show up in Mac OS. So even though it's not open source itself, Mac OS includes a lot of open source software, and Apple actually open sources some of the code for the kernel because they have to due to licensing issues. And another thing to understand about Unix systems is there's a set of standards called POSIX, and this is a set of standards that are shared by a lot of Unix operating systems, and the goal is to make programs portable between operating systems. So if you write a C program for one POSIX compliant operating system, you can compile that code on a different POSIX compliant system and have them run, and it would work. So Mac OS is POSIX compliant. Most of the Linux distributions, I think, are POSIX compliant, and FreeBSD is POSIX compliant. So we are going to talk about GNU Linux. What you guys are using on your Docker containers is a distribution of GNU Linux. So this is what people are usually talking about when they say Linux. Linux itself is a kernel, but when people say Linux, they're referring to an operating system that's part of the GNU Linux family. And so as similar as a lot of these operating systems may be, if you know a few of them, Debian, CentOS, Arch, they all came about due to some differences that might be philosophical, technical, or social, and we're going to talk about some of those differences in the next slide, especially as they relate to package managers, because I tend to think that package managers differentiate some of these operating systems more than most other things. So GNU Linux runs on a huge range of devices. So your smartphones, Android I think is the most popular mobile operating system in the world, but it can also run in smart appliances. It could run on your plane's infotainment system, or your plane's entertainment system, your car's infotainment system. So it runs in a very wide range of devices. And here are some of the distributions of Linux. These are some of the most popular ones. Debian and Red Hat, I think, are some of the most popular in data center usage because they tend to be very stable systems, both in terms of system stability and also package stability. So if you ever install a package on a Debian or CentOS system, you might notice that the versions of the packages are kind of outdated, and that's for a good reason. As Lance mentioned, you want to make gradual changes, so you don't want to update to the newest version of software every single time. So what these distributions do is they maintain stable packages of software, and that's what you want in a server environment. But that might not necessarily be what you want in a desktop environment, where you might always want to keep your packages up to date, and that's where distributions like Gentoo and Arch Linux come in. They're both considered rolling release distributions, which means that they release new packages as soon as they're updated upstream. Obviously, the downside to that is less system stability. You might update a package, it might destroy your system, and you would have to, if you don't have a backup, then you're going to have to reinstall the entire system. And we want to minimize downtime if we're managing a bunch of servers for user-facing applications. So we don't want to. Yeah.
Well, I just wanted to mention one thing as well. So as I mentioned earlier, a lot of things with system administration, we don't want to change things that often, and then there's that conflict with developers wanting to use the latest and greatest development libraries. So a lot of problems, what happens is if you use something like RHEL, you're probably using packages that are probably 3 or 4 years old. Probably wondering, why are we using something like that? Well, the thing is that containers change that. So the base operating system can be whatever, but containers, you can install whatever software you need as a developer and deploy it as you need. And that's kind of where DevOps helps kind of combine that. You find ways of utilizing the base system with newer software that you need to do and set things you need to do.
And I think we had a problem with some Gentoo packages updating recently, right?
Oh yeah, we have that. Yeah, that's the problem with rolling releases.
And the really nice thing about using things like Arch Linux and Gentoo for desktops is you can use the default package manager, which is what you generally want to do. So you don't have to compile your own packages, and you'll still have up-to-date software. The thing about Gentoo is it actually builds the program when you install it, so it compiles the program on your computer, which you might not want if you're installing something that's super big, like a web browser. So at the OSL, we run Debian, we also run CentOS, and we run Gentoo. We run Debian on our workstations. We run CentOS on all the new servers that we're spinning up, or all our managed servers that we spin up. And then I think Gentoo is on some of our older infrastructure. So there's apparently a pop quiz. So what are some of the different types of operating systems? Yes.
Embedded.
Yes. Somebody said
RTOS, real-time operating
yes.
system.
Real-time operating system. I think we got all of them.
Yeah, awesome, yeah.
And what constitutes a distribution of Linux?
Software kernels.
Yes.
Yeah.
But what makes a Linux distribution a Linux distribution?
The kernel name.
The kernel. Yes. So a Linux distribution is an operating system that's powered by the Linux kernel. So how is Linux different from Windows or Mac OS? It doesn't what?
Linux uses that kernel, whereas Windows doesn't.
Right, yes.
Well, they
What
have-
about other differences?
Exactly.
Yeah.
It's free.
It's free. Yep.
It's free.
And Linux is open source. Windows and OS X aren't. How is Debian different from Gentoo?
Package manager.
Yes, package manager. What specifically about the package manager?
Debian comes with app, and Gentoo, I think, is Pac-Man.
Portage.
Yeah.
Portage.
Yeah, Arch Linux uses package manager.
Yeah.
So Debian's generally more stable than Gentoo because of the packages. Gentoo, it's a rolling distribution. You also compile the packages from source every time. And there's further reading if you want to read up more. There's a CS312 class, Linux Systems Administration. I haven't taken this class, but I've heard good things about the class from somebody here who has.
It'll be taught by Brewster.
Yeah,
Yeah,
it'll be taught by Bruce.
we used to run that course, but we're no longer doing that. Someone else, I can't remember his name, is doing it now. But we have all that course content online if you want to check that out.
And then if you want to learn more about operating systems, take CS344. That's what I'm taking right now. And if you really want to dive into operating systems, I think you have to take this. But yeah, CS344 or 444. And then we have some free resources here. I don't actually think that second link is free. I think it's to an Amazon book. But yeah, the first resource is free. So if you want to learn more about operating systems, you can click on that link. And then we're going to talk about docs next.
Okay, so in this lesson we'll go over the basics of finding help. We'll start by looking at the man pages in Linux and how to make use of them. We'll then look at project documentation and how it differs from man pages and why you might want to use project documentation instead of using a man page. We'll conclude by looking at the messaging platform, different messaging platforms that you can use to communicate with coworkers or your open source projects in case you wanted to ask someone a project instead of going through the documentation. So usually, whenever you use a command in Linux, or maybe even any, any like a script or software tool, usually you pass in a --help option to get the usage of that command. It can tell you really quick what that command does and what all the different options the command has. This is good if you want a quick reference to get a specific what a specific flag does, but it doesn't. It's not really good at introducing what how to use a software tool for the first time.
Hey,
So-
Mohammed, could you introduce yourself real quick?
Oh, sorry. Yeah, I'm Mohammed. I'm currently a junior at OSU. So usually you type in man and the name of a program or file or even a function to get the man page for that specific program. You use the / to search through the man page. You use the the N, and after you find the first keyword, you use N to move to the next keyword. You use P to go back to the previous keyword. So this shows the general layout of a man page. It usually has a name, includes a description of what that specific tool does. It includes a synopsis or a syntax on how to like type it out. And usually there are other parts of the manual that can be very helpful, like how flags to pass into to the program, or the contact information of whoever wrote the manual, and possibly other relevant information. Oh yeah, and usually that's what not every man page has this. So usually it's the good man pages that has all the options listed out, and contact information, examples on how you use it, and also relevant commands. So usually, you can type in man to get the information for any program, but sometimes there are similar programs, but they're in a different section of the man page. So you have to type in the what section it belongs to get the specific specific program. This shows an example with open. Like there are two types of open. There's a system call, and there's a Linux command for open. So usually when you type in open, it defaults to the lowest section, and that's section 1. Section 1 is all the different Linux commands. So we will show you the documentation for the open command. If you type in man2 open, and then we'll show you the documentation for the system call. Yeah, and this shows all the different possible sections for man pages. I want to show a quick demo of so SC Shadow is a...
You might make the text bigger.
Okay.
Yeah, you should do that inside of the container.
Because container doesn't have the Etsy Shadow.
Oh, it doesn't? Oh. I didn't realize that.
Oh, does that have a man page for it though?
It doesn't.
Oh, that's right.
Well,
Control Shift plus.
it might not work, and it's different for everything, all the terminals.
But usually that's the command what you use. It depends on the terminal.
Control Shift plus.
Okay, so Etsy Shadow is a file that contains password information. Now I want to look at learn more about what that file does. So if I type in man shadow, oh actually, yeah, I think it's usually it will show a library function, a C library function called shadow, but I think maybe it's maybe the like the GNU compiler is not installed here. So yeah, by default, like this shows what the shadow file does, and it's in section 5. But okay, let's try.
Cron tab is a good one.
Okay. Yeah. So cron tab it defaulted to the lowest section, so it shows us section 1, which is a command. So it shows us the command cron tab. But what if I want to learn about the file cron tab? So I type in man 5 cron tab, and that shows us information for the file instead of the command.
How do you know, like, how many sections there are for a command?
I'm not sure. I think
The where is command can help you.
I'm actually not sure.
I think the where is command, if you have
Oh.
multiple different commands that map to the same thing, just where is, then whatever it is, and it'll say like,
Okay.
how, like which pages there are and what commands you can run, and
Mhm.
what files are associated with the document you want.
Yeah. So besides man pages, sometimes the information you want to like learn something for the first time, and that's where project documentation is most useful. In addition to providing a reference, project documentation also like has most likely has a tutorial and that introduces you to the project like a software and how to use it. It can also answer questions if you wanted to contribute to the project or learn more about internals. And sometimes man pages can be outdated, so if you want the latest information, then the best place to go is to the official project documentation. Now we'll discuss the different methods of communicating. Sometimes the information that you're looking for is not available in documentation. So you want to ask someone who's probably an expert on a specific thing. So these are different communication methods. For now, we're just going to go over IRC and Slack. So IRC is a protocol for text communication. It's a very old protocol, first developed in the first proposed in the early 1990s. Now, this protocol is implemented by many servers around the world today, and some of the earliest IRC servers were hosted here at OSU. You can use it on a lot of things. Like you can connect to an IRC server using your terminal, or a GUI IRC client, or even through your web browser. This shows an exercise on how to get on IRC, but I don't think we have enough time to go through it.
No, we don't.
Yeah, but it's a good thing to do on your free time. You can set up, if you have access to the OSU servers, you can set up a persistent session, like using screen, so that it stays there, and you can connect back whenever you want, and start like a IRC client, such as WeChat or IRC. In addition, so WeChat and IRC are terminal-based IRC clients, but there are also GUI-based IRC clients such as HexChat, MIRC, and Kiwi IRC. And they're very similar. Maybe the GUI, and in terms of features, they barely differ, but it depends on what you're most comfortable with, what you're most comfortable using. This shows how to connect to the Freenode server using both WeChat and IRC, and how to register a nickname and connect to the DevOps Bootcamp channel. So yeah, you can do that if you decide to follow the earlier exercise and set up a persistent IRC session. Then this is how you can join the DevOps Bootcamp channel. Although I think it hasn't been active in a long time. Yeah, these are common IRC commands. You can list all users in a channel. You can list all the channels. You can see the users currently in a channel. You can learn more about who someone is by typing who is and their nickname. Or you can get help to get other commands. Some IRC tips is that you can usually autocomplete the nickname of someone using the tab. So you don't have to type their full nickname. You can also so we didn't we're going to discuss this in the next slide, but those symbols are used to indicate status. They're not part of a nickname. So if you see someone with those symbols are under nickname, it's you don't usually include them if you wanna message them or through IRC. ChanServe and NickServe are robots in Freenode that deal with the management of nicknames and channels, respectively. So if you want to learn more about like the different commands that you can send to them, you can message NickServe help or ChanServe help for each one. Some useful IRC jargon. A channel is basically a chat room. And when you say ping or pong, that's usually a way of telling someone that you want to talk to them. So if I type in the nickname of someone and I say ping, that means that it indicates to that person that I want to speak to them. So at a later time, they might respond pong, and that's when I know that they're available for discussion. A hat, which is this at symbol, indicates it indicates who's the admin on the channel. So if you see that symbol next to someone's nickname, then you know that that person is is an admin. Nickname, Nick is your nickname. Sometimes, even though you might set up a persistent IRC client, but sometimes the connection get lost. So, and we call it, this is called the net split when because the IRC it's like a distributed has distributed servers like around the world, and if like some servers go down, then the users who are exist on that server may not be able to like to connect to a specific channel. So they might lose connection for some time, but after some time they'll usually get back in. And Klan or ban is like forcing someone off of a channel. Slack is a more modern messaging platform. It includes has desktop and mobile clients, and it has a lot of features for both platforms. It was launched in 2013. It was originally started as a messaging platform for a game development company, for developers to communicate for their upcoming game. Now the game didn't turn out to be successful, but Slack itself turned out to be very successful, and now it's being used by many companies around the world as their main communication method. It has a lot of features like emojis. It's proprietary, but there are clones that you can use to host your own server in case you don't want to use the Slack servers. And yeah, many new projects now opt to choose Slack over IRC because it's way easier to use and has a lot more many features. And we have a channel on Slack. I think if you have an OSU account, you can log into that channel. If you don't, then we'd have to invite you. And yeah, if that's the case, just send us an email and we can set that up. Okay. So the best way to ask for help is to think about what exactly is the expected output that you want to see, and if you don't see that, think about what the actual output is. After you think about those two things, you can Google the problem, look through the documentation, skim through to see if there's anything relevant to help you solve that problem. If all else fails, then you're in a good position to ask someone else who can help you out and explain to them what the expected output is and what the actual output that you see. Okay, yeah. Now we'll move on to lesson 4 for shell navigation.
Hello, my name's Hunter Lannon. I've been with the OSUOSL for about 7 months, and I'm going to be talking about Bash and shell navigation. My plans are to make it more of an interactive session than anything, so I'm just going to take a seat. Hopefully the link works. Okay, so this lesson is going to cover what a shell is, the different types of shells there are. There's a lot of shells. There's many under the sun. Basically, anything that ends with the 2 letters SH is a shell. The purpose of a shell, navigating through an operating system, how to write scripts to automate tasks and make things easier for you, tips and tricks, and using text editors in the shell. So the original shell is SH. This is the Bourne shell. It was developed in, I think, the 70s, and it's the de facto standard for POSIX-compliant operating systems. It's kind of the golden standard. When developing a new shell, they tend to try to be backwards compatible with SH, which causes a lot of bloat. Especially in Bash, there's a lot of things that kind of fall back on the old SH standard. Then you got Bash, which is the most common shell out there. It's on most Linux distributions by default. And then you got CSH, which is on FreeBSD normally. And I think our school servers default to that, or TCSH or something. Then you got these kind of new hip shells that try to offer more features and functionality and offer simplicity. ZSH is becoming really popular. A lot of people at OSUOSL start to use ZSH. I've tried looking into it. And then Fish, one of our students uses Fish. I don't know a whole lot about it, but it offers a lot of completion and convenience things. So there's kind of two basic things that a shell accomplishes. It offers some form of logic for branching or looping, and the most basic of a shell is it just runs a program and gives it some sort of data to work with that changes how it executes. So to just invoke a basic program, you just type the name of the program and press enter. And basically what it'll do is it'll just load the program data and start executing it. And then there's some flags, and that's defined by the program. See if we can get a quick example. Something like that. There we go. So an example of a program, a really simple one, is echo. Basically what that'll do is it'll take all the things that you put after echo and it'll put it onto the screen. If you don't put anything in it, it'll just give you a blank line. But if you pass it some arguments, like hello world, it'll then print out hello world. It also has some options. You can always check that with the man page. You can say -n, and that will modify how it works. It won't print a new line at the end. It will just put it right there before the prompt. What's the modifier key for i3 on this?
Windows key.
Oh, okay. My bad. And then there's also kind of an environment. Linux in general processes have the concept of an environment where you have kind of key value pairs that are stored in memory. There's a lot of built-in ones, kind of like the path variable, the user, the shell, which is kind of like a path to the shell that you use. And these are denoted with a $sign like this, so you can echo out stuff like that. Like user will print out the username, which is OSU admin in this case. You can also print out shell, which is the path to the shell that we're using, which is bash.
You might switch over to the actual container so you're using the same
That's
thing.
true. It's in the, we just close out of this one and
Yeah, just exit out of that. It should go over to
Okay, cool. That's kind of a list of everything. Arguably, the path variable is the most important variable in a shell. It is what the shell uses to determine where the programs are located. So for example, echo isn't just some program in the middle of nowhere. It has a location. You can find that using the which command. So you can see from the which command that echo lives in this path right here. And if you open it up, it's going to be mumbled garbage. It's just binary data. It's just like a normal program, just like you would compile. And basically what happens is whenever you type in a command, what it'll do is it'll look through the path variable, and it's separated by colons, and it will search each directory that's listed in the path variable in order until it finds a program that matches your name. There's the concept of a pipe, which takes the input or output from a command and kind of redirects it. It kind of uses the concept of Linux's file system. Everything in Linux is basically a file, and it's not necessarily a file that's stored on disk. They kind of abstract a file away from actual physical storage. It can be in memory, or it can be actually on the disk. There's actually a type of file called a pipe, which is basically what this pipe symbol does. It basically is a file that holds data, and then when it's read from, it removes the data from there. And it adds the kind of concept of a stream where you put something in, and then someone reads it, and it's gone. So you can use pipes for a lot of things. I'm just going to create a sample text file. So, another program that we use frequently at the Open Source Lab is grep. And basically what it does is it reads input, which is by default the keyboard, but you can also change that using the pipe in a shell. And essentially what it'll do is it'll search each line for a certain pattern, or you can specify multiple patterns, or you can pass a bunch of arguments to change it.
We just realized that we're not streaming this side of it.
Oh no.
That's
I'd take like 5 seconds. And just
Okay.
throw it to the rest. You can keep talking about grep, I guess.
it's only showing the slide online, so
Yeah, so grep's really great. I actually wrote a script a while ago that basically cleared out our DNS system for things that weren't active. And it basically used text patterns in the output of a ping command to remove hosts that didn't respond. Basically deleted the internet. So we can also use cat to look at the file. So we have this file. It's got 3 lines. It says this is a test, this is the second line, this is the third line. What we can do is we can take the output from this command and we can basically shove it through grep, and we can specify a certain pattern to look for. So like if we want to look for the word test, it'll print out the first line, the whole line that has the word test. You can do second, or if you're fancy, you can do stuff like regular expressions. You can do second or third. And I'll print both the lines that match both of those patterns. So there's really a lot of things that you can do with the command line. In general, the command line isn't like a programming interface. It's more of like you use other people's programs, use minimal logic and searching, and you kind of make these programs do work for you. And then you also got the file system that you can navigate around. Like a lot of things in Linux, the file system structure is based on a tree. It starts from the root directory, which is just denoted by the slash. And you can change into that using cd and then followed by the directory name. You can cd into basically any path that you have permissions to enter. More on that later. You can specify relative paths, so if there's no slash sign at the beginning of the directory, it basically looks at the current directory that you're in. You can go in here and look at everything in there. You can go down a directory, which is denoted by this. There's also just a plain old dot, which is the current directory that you're in. And you can look at that. That doesn't show a whole lot of information. And just the plain old cd command returns you to your user's directory, which is your home variable. Yeah, you can also just use the little squiggly line here to go to your home directory. So if you want to go to the root directory, you can go back to your home directory like this. If you have other users and you're super user and you want to go into the directory structure and for whatever reason, maybe good, maybe bad, hopefully good, you can type their username in here and that will turn you into their directory, and you can enter all of the stuff after that to go deeper and deeper within their file system structure that they have. So I guess we can just go through these commands. So pwd prints out the present working directory, which is kind of where your shell exists in context with the rest of the operating system. It also is kept tracked by a variable called pwd. You can just you can use pwd to get that. If you go down one directory, it says that we're /home instead of /home/dobc, so we went down one. You can also see the pwd by doing this. It's the same thing, it's just more verbose, and it'll hurt your pinky because you're pressing shift too much. You use ls, which is basically shorthand for list. A lot of default shells setup have things called aliases. which are basically like keywords that map certain words to other commands. Default one usually is LL, which lists everything in the directory. On the left, it shows like permissions, the PID, I think that is, of the user group, and size, and a whole bunch of other information about the files. CD is a built-in to the shell. It's not an actual program. It's just something that's implemented by the shell interface itself. You basically just change into another directory. You've already seen that. Echo command takes everything after it that isn't preceded with a dash and puts it onto the screen. And the things that are preceded by dashes are called flags, and you can look at those in the man page as Muhammad described. Cat concatenates two files or more files. So if we open up a second file, just type some random stuff. So now if we list out the current directory, we can see that there are two files, and we can use the cat command to concatenate them. And if you're not familiar with computer science term, concatenate is basically you take two things and kind of put them together. So you can cat second. And all the while, you can always press tab and it will complete stuff for you. So like if there's a file called test and there's no other file that kind of starts with the same words, you can start typing it out and press tab. And it'll show you all the options that match what you've typed so far. Basically, this just prints everything out. And you can pipe this to grep second. This is the second line, this is the second line, second file. There's also a bunch of different forms for commands. For like grep, there's I think 3 different types. If it's reading from standard input, if you pipe the output from one command into grep, then the second argument by default is the pattern unless it's preceded by flags, which is really confusing, but really you just need to read the man page about this stuff. Because there's really no standard when it comes to this type of thing. There's a lot of intuition that's kind of formed over the years. You can kind of guess how things work. But usually you want to look at the man page for commands that you're unfamiliar with. Less will basically look at the output of a file, but if it's too long and you don't want to scroll up and down through it using your mouse or whatever, because we don't like to use our mice at the open source lab, less allows you to basically open up the file in some sort of scrollable buffer. So I'm going to create a new file called long.txt, and I'm just going to copy this like 100 times. So you can use less to look at it. It'll be better if I So you can scroll down and eventually we'll hit stuff like this. Or you can do man grep and you can pipe it through less, and instead of reading a file, it'll read the input that is given, which is kind of redundant because man's already opened with less or some sort of similar form. And in this command, you can also use the slash and start searching for something. And you can just press N repeatedly to just cycle through all the matches to whatever you type down there. Press GG to go to the top, capital G to go to the bottom. I think H is help. It's basically a quick guide instead of digging through the man page. I don't think there's no, there's a man page for that. N will print out all the environment variables. And you probably want to actually pipe this through less to actually get a sense of what's going on, because there's a lot to it. There's just a bunch of variables that are defined by the shell. And who am I basically just says who you are. You can also get this information by printing out the user variable. It's the same thing. You can also kind of get this from where your home directory is. Usually your home directory is named after user, but that's not necessarily the case. So the command line is really useful, but sometimes you want to do the same thing over and over and over again. You do it so often that it becomes a pain to type. So the whole idea of a shell script is that you can define a file and you can put commands in there that will run in order, and you can add branching logic like if-else, looping structures like for loops and while loops, as many of you computer science majors are aware of. And basically everything that you can do in a script, you can do from the shell. So kind of a simple example, I can just show you guys a for loop. So for the variable I in the sequence of numbers 1 through 9, we can print out I, and it'll basically print out a giant sequence. This is generally bad unless you have a really good reason to do looping. Again, you're not really trying to develop a full-fledged program in a shell because you're just wasting time, and you'll be screaming at your laptop and trying to break it. If you kind of don't want to write a full-fledged script, but you want to write something, because if you try to go back up through your history by pressing up, you can actually do that. I forgot to mention that. You can go up through your history by using the arrows going up and down. If you look at this, it kind of like flatlines the entire thing into one line, and it's really annoying to kind of go through the whole sequence of characters and try to figure that out. So what you can actually do is you can, if you press Control X followed by Control E, oh, Lenovo's have weird keys. You can change it in the BIOS.
Oh, really?
Yes, you can. So this will open up a file. If you press Control X and then Control E, you'll open up a temporary file. And what you can do is you can, I think this is now, so yeah, you just type. You can just type out whatever you want to do right here. And basically just save it. What is this? Is this Emacs?
Yes, it's Emacs.
Ugh.
You were so screwed.
Ugh. What is it? Control X, Control C, something like that?
It says it at the bottom.
Oh, it's got that capital dash whatever key notation. I'm going to need some help here. I don't use Emacs. I love GNU, but I hate Emacs irrationally. Oh. Oh, I done goofed up. It basically illustrates the concept that you can basically open up a file and have things written easily. Because if you have some sort of syntax error, it's usually easier to figure out, and kind of like you can actually separate the lines of your script. But if you want to actually just write a full-fledged script, you can do that. What would be a good idea for a script? We can do something that tests arguments. So every script starts with a shebang. I don't really know why they call it the shebang. I know that we call the exclamation marks bangs a lot, but I don't really get it. And basically you give it a path to an interpreter. So bash on most systems lives in /bin/bash. So this will basically tell the shell when you invoke this that it's going to use this interpreter for the following commands. So let's see, what does the slide say? Yes, okay. So you can also add some conditional structure to it. So you can say something like, if some command, and it will run the command, if it returns successfully, then the following something happens. And it ends with phi. That's kind of like the basic if condition. It's really sloppy. It doesn't make a whole lot of sense. You don't really even need to use a semicolon here. You can get rid of this and put this on the next line because bash works on white space, but I think it's more clear if you put that there. So we can take some command that always exits true, so we could say echo hello world. LW likes to escape in there. And we can I didn't really think this out too well. So this is going to, oh, we also got to add executable permissions as we learn. I'll basically always return true. because the echo command does not return failure. But if we put some sort of weird conditional in here, as bash will allow, there's this kind of structure with the brackets. You kind of have to look into the documentation a lot to kind of figure this stuff out because it's really, really obtuse. But if we want to test whether an argument is empty, we can use -z, and then I think it's the name of the argument, which we're just going to say the first argument. So in bash, an argument that's passed to the shell is just anything that follows the script's name. So it doesn't matter if it's a dash, if it's an option, or if it's just some plain text, because that's implementation dependent, however those arguments are parsed. Bash just likes to kind of serialize everything. The first thing is 1, the second thing's 2, second thing's 3, and so on. So this should test if that is present. And we can say there is a variable passed.
Double bracket or single bracket?
Oh yeah, you need to.
Bracket. What's your bracket?
Oh, geez. This is the struggle of bash.
Exclamation point to the inside.
On the inside?
Yeah.
Oh, no.
And keep the space at the beginning. You have to have space.
Yeah.
after that.
Ah! We passed a variable and we checked it. It was a struggle. Yeah, it's kind of inconsistent. There's like 12 different ways to do a single thing. So in this case, this script basically says if the output of this command is equal to root, then print out your root. Otherwise, you say, oh, your name is this. This is where you live. This is your current directory, and this is the name of the computer that you're on. This construct of this $sign in the parentheses basically says run this command inside its own separate shell and then return the text that was outputted. And then the equal sign is basically it just compares it with a literal string. So to run to execute basically any script that you create, you have to give it execution permissions, which we'll go more on later, but basically every file that you create has kind of like a default permission, and you have to set everything manually. And when you go and execute a script, remember how everything is checked with the path variable? Well, because the current working directory usually isn't in the path, you will get this is not found. But you say, it's right there. Why can't you find it? That's kind of dumb. You have to precede it with dot, which is the current directory, and then the slash sign to indicate that you're trying to access a file within that directory to get it to run. This is kind of a security thing where maybe someone transplants some sort of file that you use or some sort of program that you use a lot, and it's actually something malicious in your current working directory. So in general, it's a bad idea to add that to your path, but but we could totally do that. So we could just set a variable.
By the way, we got about 5 minutes left. So I don't know if you want to move on or continue on after lunch. I know that lunch is here.
Okay. I guess I can move on with that point.
Let's move on at least for the next couple minutes and see what we get into.
So there's also a couple of meta symbols within bash. There's the concept of the star, which basically expands everything that matches the text before or after the star. It's best illustrated, so if you were to list off second.txt and test.txt, you've then typed a lot of things and you already knew that they were there, so why did you type them? You could always just do star.txt and it will match everything that ends with .text and will return it. If you want more useful information, you can just use the -L and it'll tell you everything that you could possibly care to know about it. You kind of got the or and kind of construct that you see in programming languages, and all that does is compare the exit status of a program. So if you guys have ever done any programming, every program has a return status, like the main function returns 0. In Linux, 0 basically is true, it returns successfully, and everything else is false. So if a program encounters some sort of error and it returns like 1 or 6 or whatever, and you try to do something based on that, you can use or and to evaluate those expressions. So, for example, here it says echo this is a error message, and it does this odd thing where it redirects standard input into standard output, and then it pipes that through grep with error. Okay, yeah, so that shouldn't get caught by grep because it's in standard error, and you pipe standard output through grep. It's still going to go to standard error.
Oh wait, yeah.
Mm-hmm.
No wait, does it copy it or does it move it?
It moves it.
Okay.
There's basically also this concept of the bang, which if you use it twice, it uses the last command in your search history, and it just basically does the exact same thing. If you want to add something on top of that, you can add some sort of string onto the end, and it will basically expand to the last thing. You can see it says ls star.text, list all human. Usually it's -lah, but it accomplishes the same effect. Also useful, kind of loops sometimes. It really depends on what you're doing. Most of the time you really don't want to be looping in a bash script, because if you're introducing loops, you kind of do something that's more suitable for a programming language, unless it's something extremely basic. You can set variables, basically just say var equals value, and you can print out this variable called var using the $, and it's just called value. But oddly enough, if you open up a new shell and you try to echo that out, it doesn't work. But you can make that work by saying export, and basically you're saying that any program or process that you open from this point on will now contain this variable in its environment, which is something that's tracked by the Linux operating system. So we can open up a new shell, and I believe this should work. Yeah. So that's how you kind of get variables to affect other programs. Yes?
If you open up an entirely new shell from another window, will it preserve that var?
No. So basically Linux has this process like hierarchy. The first process will start whatever. So if you have the first process and it branches and you open up a bash shell, and then you set the environment here, the environment only gets passed on to its children, if that makes sense. If you create a new process, it'll have it. But if you create another one from above the hierarchy, it won't know anything about it. It doesn't care. It's kind of like genetics in kind of a weird way. You can also use these weird backticks. It kind of looks like a quotation mark, but it's actually the symbol that's right by the tilde. And basically what that'll do is it's kind of like mathematical parentheses. It'll evaluate that expression first, and it'll substitute the output to the command that follows. And basically scripting is basically just combining all these things together using other people's software that they wrote to make something more useful. I don't know. Lance, do you know what set does?
That sets various settings within.
That's okay.
So a useful setting you can have is like set plus X, and that will print out the actual command that you're running inside of the bash script, or you can do -E, and that will exit the script if there's any kind of error.
So sets something. I'm not going to look through the man page because I don't have time. It sets a variable, which is just a CIDR notation for a subnet. It's basically the most common.
That's creating a bash array specifically, like a very special bash array.
This?
Yeah, I know the set-A is.
Oh, okay. So create.
I think it's an associative array or something like that.
Yeah, I don't know anything about bash arrays. I tried. I've tried. So it creates an array, blocks IPs, and a string that represents IP address range. And then it saves the output of this command, fping, and it basically pings every computer within a subnet. This is going to be a lot of computers that are getting contacted, potentially. It's 256 cubed. because that's the entire
No,
sub.
No, slash 24.
Oh, it's /24. Yeah, so it's only 256, but there's not necessarily that many hosts, and it will pipe that through grep to see if something's unreachable, and then it stores it into this variable called IPs, and then it loops through all the IPs in this output, and then it will do, it looks like a scan on port 22, and if that's successful, then it will set the IP variable to whatever this construct is.
It changes the way the variable is printed.
Yeah, so it just prints it kind of funky, and then translates. Yeah, it does something weird here.
Replace each sequence of a repeat character that is listed in the last specific set with a single occurrence of that character. That's what that TR minus S is doing. So it's replacing new lines with slashes.
Hard to say, just looking.
I think it's replacing spaces with new lines.
Basically, the whole gist of this is to get a list of hosts that are unresponsive to a ping. And
That's
this,
just an example of things you can put together.
yeah, you can do a whole lot of stuff. You have to really troubleshoot these things. They can be very frustrating. You can also define functions. You can also just define a plain function in your shell. I won't go through that. Basically, it's just like a mini script that has its own set of arguments. It just exists in one file instead of spreading it out throughout multiple files. There's a bunch of variables. The variable is preceded by the $, and the star means all arguments pass through the script. The $sign is the return status of the last command. 0 is true. Everything else is an error happened. The @ is all arguments pass through the script after the script name, not including the script name itself, because oddly enough, the script name is included. The CD path, which is a colon delimited list of places to look for directories. The home, which is your user's home directory. IFS, internal field separator. I believe that should just be like a colon. Odd. And then your old PWD is the last directory that you're in before the current directory. You also got the path, which is probably the most important variable. It's used by Bash to determine where programs exist. Present working directory is the current directory that you are in, your shell. The shell is the path to the actual program that the shell is. UID is your user's ID, as we'll go on in the next section. And the dot is representative of the current directory. Dot is the parent directory. You can just print out the current directory like this. You can print out. You can chain these together, and this will take you to the root directory. And the / separates directories, which is how you look up files in the file system. We can run tree f.
But don't worry about that.
Yeah. It basically prints out literally everything. You also got the asterisk, which will match everything, does expansion. In kind of an odd text matching language called a regex, you can use the $sign to represent the end of a line. You can use curly braces to represent a set, which Bash will basically expand everything. It'll basically make a set of things. So the example, this ls foo bar basly thing will expand to ls fooly thing barley thing basly thing. And anything that is a Bash character that is recognized as not to be like normal text, you can just put a / in front of it to get the regular text meaning from it. You can basically autocomplete everything. If you're looking up a program and it's like really long, there's a couple of them out there. Basically, you just tab complete. If you press tab twice, it will show all things that kind of match it. But if there's only one thing that matches it, if you press tab once, it'll basically autocomplete it for you.
I think this is a good stopping point for lunch because you're getting into text editors next. So let's go ahead and continue this after lunch. We have pizza in the other room and some drinks, I think, and some other stuff, cookies, maybe? Yeah. So we'll be back right about 1. All right. check and make sure we do it.
All right, picking up from where we left off, you tab, it searches your path for programs, or it searches for files in the current working directory. If there's multiple matches, you press tab twice and it shows everything, and you can start figuring out what you really want to do from there. So, in most scripting languages, there's an environment variable called editor, which determines what command is used to open up temporary files, like when you do a commit and git, or if you, there's a couple other applications. They're pretty rare, but it will open up this text editor, and by default, in most systems, it's going to be Nano because it's the most intuitive and easy to get into. Basically, you just start typing when you want to save, you hit Control X, and then write the file name and save it. I really don't like it because it's often been accused of corrupting files somehow. I'm not sure if that's exactly true, but there's also other ones like Emacs and Vim, and there's kind of this cultural war over both of those. So it says that Nano is a great terminal text editor to start with. That's because you really don't have to learn a whole lot of hotkeys. Anything that you need to learn how to do is basically printed at the bottom of the screen. There's a nice little help menu hotkey that you can look at and get all the help you want. But in editors like Emacs or Vim, if you look at the help menu, especially for Vim, it's incredibly chock full of information and a lot of confusing terminology that you might not need to know. You probably don't need to know. You'll need to know if you're like writing plugins and stuff like that. But Nano is basically like any word processor. You just type and it shows up, and when you're ready to quit and save, it's pretty intuitive. So, yeah, you could use it to create basically any script that you want. There's no difference in text editors in that ability alone. This script would basically just print out hello world, but it would save it in a variable for demonstration purposes, I guess. So to pass arguments to a bash script, like we spoke about before, basically anything that goes past the script's name is passed as an argument, and they're incremented one by one. So the first thing after the script's name is the first argument to the script. Second is variable number 2, and the variable using the @ sign is all the arguments excluding the script name, but if you use the asterisk, it will actually give you the full arguments, and that would include the actual script name itself. To read user input, you use the keyword read, which is pretty intuitive. I believe it's a bash built-in, but I'm not entirely sure. Basically what it does is it waits for you to type something in and press enter, and then it saves whatever you typed into the variable that you passed to it. So say read word, when you type word, or the word that you type out, basically it would store it in that variable, and in the echo statement below it says your word is, and then the $sign expands that variable into whatever you typed out. And if you use -a, it puts it into a bash array, which is useful for iterating over, I suppose. Yeah. So if and else statements are used for basic branching logic. So if you say like the input or the return value of a certain command is 0, meaning that it succeeds, then you can continue doing something else. If it fails, then oh, well, we don't want to do this thing because this thing didn't work. This is basically like basic programming, except you really don't want to use a whole lot of branching logic because it gets really, really messy with bash, and if you're doing a whole lot of that, you might as well just be doing it in Python or something similar. So this will basically check the first argument that's passed to the script, see if it is equal to foo, and then it will print out you said foo. Otherwise, it'll say you did not say foo. So here are a couple of exercises. We'll give a brief moment to go through these. The first one is using the tar command, which is used to basically grab a bunch of directories or files and basically shove them into a single file. Write a script named backup.sh, which backs up the DoBC user home directory into a file /temp/dobc backup.tar.gz. You should probably be using the man page. If you have any questions, just raise your hand. One of us will get up and help you out. If one seems too daunting, because the man pages can be pretty obtuse, just feel free to move on to the next one and ask questions later.
Yeah, go ahead and get started.
Don't forget the shebang at the top. There's a question.
tar-H.
Try tar dash help. There's like two standards, -H and dash help. Nothing? There's tar on the system, right?
Maybe tar doesn't have that. There's not a slash tag directory. Oh, no, yes.
There is other stuff.
Yeah. Because the man is for.
I think it's only for building.
There's no man pages for tar?
What? Actually, though?
Oh, if they, because the container is installed without any of the man pages, but I set up the configuration so that if you reinstall the package, it should install it.
Surprised we didn't catch that.
Yeah, for this command, I mean, I tried to add the packages I know we have, but if you do yum reinstall tar, it should, in theory, install the man pages now.
I mean, I can just write the relevant flags because I think and like describe what they do because it's just the C and the F, and I don't think you need any decompression flags to figure that out.
V is nice.
It could be, but
Yeah, put yum reinstall tar up there, and then also.
well, is that actually the command?
It's yum reinstall tar. What was the?
How's it going, Mohammed?
What was the stuff we have up there?
You like man pages?
Here, try doing yum reinstall tar on here actually.
Yeah, just do it there. So we got a sudo first.
Sudo yum reinstall tar. Well, wait, what? What are you doing?
Do enter and then tilde dot, and that'll lock you out. Yeah.
And then yeah, the default password. Okay. Sudo yum reinstall tar. I guess that does work. Maybe. Nope, doesn't work.
Wait.
Nothing to do.
No.
Can you like force it to reinstall?
It's supposed to do it.
Is that a thing?
No.
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 Why did reinstall not do anything? Try it again.
Yeah.
Because what do we get? Installed package, not available. It even gives you a fancy version number and everything. It's just it's not available. Does Yum update?
I should try yum install tar.
Yeah, here, put the assignment back up, and we'll just go.
Wait, did it work?
Oh.
So they want you to create swell colors.
Did it work? Man page?
No.
Try yum install, sudo yum install tar. I tried that and it worked.
Sudo yum install tar?
Uh-huh.
Use your home directory.
That worked for you?
Yeah, yeah.
That's really
Yeah, I know how to do all the echoing and stuff when I've written scripts before.
Yeah, so you have the
Oh, you got it. Nice.
Or, you know,
Yum update.
So we
And then it's not for like 2 minutes, so maybe within that 2 minutes.
Wait, it has to install.
Nice, you got it.
Installing everything.
Everything.
Oh, wait.
Oh,
I thought it
whoops.
Wait a minute.
Wait, are you upgrading every single package?
Can I cancel this?
Don't, just let it go.
Oh my god.
Feels bad, man.
Did you type in upgrade?
Just type yum
Upgrade.
upgrade. Nice.
Feels bad. I was like, why is it updating glibc? That makes sense.
Oh wow, that's a huge upgrade too.
It's done. Surprisingly fast.
Yeah.
I'm giving some up here because the man pages are gone.
I think if they do yum upgrade tar, that'll work.
Yeah, I'm gonna try to describe it as best because it should have. I don't know. It should have existed. It didn't. You can look online too, since tar is a very common command. You can look online in like Google or something for just tar commands.
Tar man page.
Oh, you can?
Don't know what I'm supposed to use it for.
Well, back up the home directory of the DoBC user.
Basically, the whole idea behind it is that you take all the files within the subdirectories in the user's home area, and you squash it into a single file. It's called a tarball. What's called a tar file. That's like the idea. You like stick them together with tar.
You know, I've never heard of that.
It makes sense, and then you compress it, and it's a tar ball.
Well, it stands for tape archive.
I like to think that it's tar, like physical tar.
Find out what the directory is, find out all the files that are in the directory.
Yeah.
Is a lot of.
What you have, tar can compress directories by themselves, so you say to compress the current directory, it will just get everything in that directory for you.
Okay. And that's one of the tar commands.
Yeah, that's what I was trying to. The C command will actually say like create an archive file. I'm gonna do the -f command, which is like output to this file kind of thing. And I think yeah, it already does that.
Oh, okay, cool.
So just tar.
Yeah,
Well,
you want to take this
that will
That's the
directory
part,
here.
the part that I know.
PWC.
So it shows how to use, it shows what tar does.
And they want you to put that. They want you to make a tar
Yeah,
file.
no, that's the man page you're supposed to be for.
/10/q.
The man page is on
DoBC backup.
So
That's part of it.
so explain this. Tar is basically like
The best way to do
the
it,
Linux version
you
of
can
Linux.
just do it.
It's like almost identical. And what you do normally is you would create a .tar file from
You do
a
a tar and
files,
then-
and it will take
Oh,
that
it's
list
all
of
tar.
yeah, that's what it'll turn
It's
into.
not a function.
There's like
Or it's a program.
Oh, I thought it was a function.
Oh.
Okay.
So tar is a program that takes a list of files and puts it into one like big file called a tar file, which is ended.tar. And then normally, tar can do this by default, but it can compress it into various different options.
or dash.
Normally, there's like gzip and bzip are the two really common ones, and those end in .tar.gz or .tar.bzip or bg2, depending on how you set it up. And yeah, and tar can actually compress it.
Trying to play it cool.
So you don't have to actually
So when you say RDS, you're meaning
the tar
directory.
file. Well, after the directory goes into the tar file, you can compress that. Yeah.
I never get the tar command right. Too many options. It's like to extract something, you have to pass like 3 options. And it depends on the file extension.
Look at my pictures when I got
You can use a bin too, and it's the same thing. Yeah, it's the same thing. Different ways to do stuff. Yeah, so what you
Tiny.
do
You need to write it bigger.
is to create a file command that copies your home directory.
Dude, how do you do that directory?
That's your
And can you find out the directory by default? So it depends on how you're specifying the command.
Oh, so we're not doing any flags or something?
You have to have flags if you're creating an archive. Well, here, 1 second. I know, this is kind of, with the man pages it's easier, but.
Also looks like the dash on it. You can try doing it just on the like, see like he's doing it just like that. Like you could just do it for the command line, you have to write function for it, right? You don't write it for everything.
We should probably move on here in a few minutes.
Yeah.
You don't write you don't have to write a bash script. You can just literally type it into your shell and it'll do it for you. So
That's the problem, is I don't know.
okay, so what you need
How to do what you want me to do.
so yeah, so it actually is creating a tar file, but because you don't have the -f command, which is output file, it's spitting it out to your terminal. So that's the entire tar file you're seeing right there in your terminal.
You probably have man tar now.
Yeah.
You can not go that direction.
So no, it takes a list of files and then
I don't know how useful it will be. Because
yeah, put it after the because that F flag. Yeah.
Alright, we got the man page for tar on the big screen. And it shows like, is it not?
Yeah, the first six. Yeah.
Hmm.
So the example.
You put that.
Or is that file what
file
we're needing?
Usually just do GF has the extra one or use now.
If you don't, then it's that print out.
So would the name be?
So that, so
It's usually like slash mount signal, slash media or something, depending on the output.
Using your files. Oh, because
It's probably a slash media somewhere, which uses DF dash.
So that's why in the so we tried to compress it. So in the what's the you gotta output it somewhere not inside the kernel. So I think
I'm torn between staying on this man page and staying here.
so it said to put it out
You kind of have to go back and forth there.
It's hard to judge.
and that's not good.
Tough crowd.
Extract. Okay, extract is the
yeah, so it
takes
extracts
the kernel
everything
and puts it in.
and
That's what I
so
was
that's kind of what that does. It's like these are the same things that are
So that what that command do is extract.
well, it's nice for like
verbose
you can turn it into a bunch of
using
files.
G's
It's hard
and
to
that's
figure out.
fine. Is what that command is trying to.
So is it supposed to be like
What do you think, Lance? Do you think we should move on?
You're not moving.
Yeah, let's go ahead and move on.
We're doing a whole new thing.
Okay.
The original
Oh,
process
so
stayed
then.
Unfortunately, we don't have enough time to finish working on these examples and we need to move forward.
Well, you didn't specify.
So we'll just go through the answers real quick like.
Speak up a little bit.
So you gotta just pseudo.
Heads up! We're going to go on, since we're running out of time.
So this is what the script would look like. It's essentially just a single command. And what this would do is verbosely it would just say which files are getting backed up and it would shove it into this file and basically just takes the directory, everything in it, and puts it into the file in the temp directory. And when you run it, it would basically print out everything that was getting backed up. And from looking at the man page, you can find an easy example of how you would look at the files in the tar. So to pass arguments to a bash script is everything on the command line after the script's name, and the variables are numerated based on their position from the name of the script on the command line. So this is how you would print out the arguments passed to a bash script in reverse order. And if you give the script nothing, it would basically just do nothing. It would just print out a blank line. And if you use quotes, it would do the same thing, except only the first argument would be populated because the first argument is everything within those quotes. So to read user input, you basically print out something, give them a prompt, and the -E flag, I believe, makes it so that you don't actually print a new line. So the prompt will be after the thing that comes in the echo statement, and then you read it into the variables, and at the end, you would just print it and use the $sign keyword to print out the different inputs. So this is a basic comparison on the first and second arguments. If they're exactly equal, that is that each character in the string matches and their positions are the same, then it would print out yay match. Otherwise, to say boo, they don't match. You can see how that works here. And if you want to learn more about Bash, there are tons of resources out there. I recommend looking at tutorials personally, because if you just dig through the Bash programming, there's basically this monolithic man page. It's like 30 pages long, full of a bunch of implementational details you really don't need to care about just getting started out with.
I highly recommend those first two top links because those go in great depth about Bash. And you learn. I always reference those when I'm stuck on something, and it's good to kind of have a good refresher too.
I've done a lot of Bash scripting, and I've seen a lot of scripts. I haven't seen a lot of scripts, but I've seen a lot of examples online, and it just makes you like, what does that even do? And you have to like search the depths of the internet to figure out what it does. There's a lot of really specific stuff thrown into Bash, but you can do it another way for almost all those weird syntaxes. Anyways, moving forward to lesson 5, users, groups, and permissions. Oh, we have a question?
Oh, is it just on the
What's the question?
Oh.
I need somebody to talk to you.
Oh, okay, I can help you.
Yeah.
You're the next speaker, right?
Sorry.
And introduce yourself.
Hey, everyone. My name's JJ. I also work at the Open Source Lab. I might have already helped a few of you or talked to you, but now I'm officially giving a talk up here. So, all right. Let's move on to the next section. Users, groups, and permissions. Oh, my. So, kind of bothers me that it's slightly down, but in this lesson, we'll be talking more or less like in Unix terms, or more specifically Linux, because some stuff is Linux specific. What is a user? What a user can be, and who can be a user? What a group is, and how you can act another user, and the very special user, the root user. All right. So, what are users? You are a user, specifically right now in your container. You are the DoBC user, and that's why you had to say the username DoBC when you logged into it in the first place. So, running these commands, you can figure out who you are, who's logged in, who is here, and what are they doing. Slightly different commands, but similar idea. And ID, which shows the user ID you are and the group ID you are, which is like a magical number. It's just assigned to your user when it's created. So the operating system itself knows who you are. And then when you're actually talking, or when the computer's trying to convey to you what that user is, it'll actually use the name that's specified in files. And that's also important to notice that users are not only people. Sometimes they can be just for specific programs, so the programs are not running as a root user, or not running with full permissions, but it's running as a specific user that only has access to certain things that the program needs to run. And those are technically called system users. So, what do users have? Users have a username, like DOBC, a UID, and I think the ID for DOBC is 1000, which is the default username for CentOS, or user ID for CentOS. And users also have a group that they're like their main primary group. Users also have a shell, usually. It usually is a working shell. If it's a system user, maybe it just points to a program that returns immediately and it's not a real shell. And users can usually have a password, not always. Sometimes you're not meant to log in as a user. And they can also have a home directory, but not always, because they're like a system user you're not supposed to be able to log in as. So the etc password file right here, this is a special file in Linux that says who are the users on this system and some metadata about the users. And I think it goes into, does it go into detail? No. So this file has a very specific format. If you do man password, it'll actually, well, password, passwd here, it'll actually tell you what the fields of this file means and what can be in them. But kind of crash course through this, username, oh, actually it does tell you, username, password, UID, GID, UID info, like describing the user, the home directory of the user, and the shell that the user uses, like bash, for example. And managing users and groups, servers. So, yeah, like I was saying, Etsy password, you can view the users on the group there, but then managing, you would have to add and remove, which I think is in the next section. Yep. So if you wanted to add a user, you would use user add in the CentOS environment we have there. Some other operating systems might have a different program for this. For example, Ubuntu has add user. And I think depending, even like some BSDs might have a slightly different version, but I think user add is POSIX, I think, so almost everything should have it. Userdel does the opposite, takes away the user that you were looking at. And then password, we've already run this before, and it sets the password for you. But also, if you set a username after password, you can actually change the password of a different user on the system. If you're the root account, that is. And we'll get into that later. Here's a fun little comic. Or not really fun, it's kind of depressing, but okay. So, what is a group? A group is kind of like, well, here, let me actually read the slide. Add a group. So groups are just kind of like things a user can belong to, kind of vaguely to put it. So each user always has a group that they're associated with, and user can be, well, associated with multiple groups, but they have one primary group, but groups can have multiple users in it, and just goes off of that. And with having multiple users in a group, you can actually set permissions on a file where only this specific group of users can access, instead of like having to set it for every single user, which actually isn't possible, but we'll get into later. So you have to use groups for that kind of purpose. So you can view the groups in Etsy group, which is another kind of file like Etsy password, similar formatting but slightly different, and also has its own little, I guess, format. So name, not entirely sure what the X means, and the group ID.
Is that the password or placeholder?
Well,
So I think there is such a thing as a group password, but
Is there?
it's never really used.
yeah, I've never had to use it, so if you do have to deal with it, I'm sorry. So hopefully you don't have to. So passwords. Passwords can be stored in the Etsy password file, but normally it's in a completely different file at Etsy Shadow. So in Etsy password, if you don't want to store the password there, you'd use a special symbol where the password would normally be in that file to have it say, this password's not stored here, go to the shadow file. And Etsy Shadow has passwords for each user, but they're not just passwords, they're encrypted passwords for the user, so you can't just read it and get the passwords of everyone on the system. So the password file, also similar-ish format, where it's just delimited, and similar idea. So name of the user, the hash of the password, so it's not the real password, and the time it was last changed, which can be important if you have like a type of system where you have to change your passwords like every 7 days or something. And same here, min days between changes. So that's where if a user logs in and the time since they last changed is beyond this minimum number of days, then it'll force them to change the password. Max days is similar idea, but opposite implementation. And a whole bunch of extra flags here. Days to wait before expiry or disabling, and day of account expiry. And also you can change the attributes for that using the change command. All right, so the super user, the root user, UID 0, and you can access the super user, or at least run commands as the super user by using the sudo command. And big warning, you could seriously screw things up if you're not careful with this. So like double check everything you type in before you actually run something as the super user. Another fun comic. So there is also a man page for the sudoers. This is for the sudoers file. So Etsy sudoers contains information on who can access the sudo command and what they can do what they can do with the sudo command. So for example, here's for like some stuff where these users can be like mapped to this alias just within the sudoers file, so it's easier to manage. And similar sort of stuff here, host aliases. And then some more command aliases, stuff like that. But then here's where you actually say who can do what. So the root user can do everything normally, because if they're running the sudo command, it doesn't give them any extra permissions. They're already root user. But an admin command, or an admin user, which was part of the alias up here, DoBC admin, they can run any command, and also the special user here, they don't have to type in a password. And let's see here. And if you're a DoBC student, which is another one of the aliases up here, there, they can run only specific commands, kill and, what's it, sue? Which, yeah, these two commands, they can run as the super user, I believe. Don't quote me on that. I'm not actually 100% sure. So, acting as another user. So, if you wanted to pretend to be a different user than yourself, you'd use the su command to do that. So, sujo says, like, I want to pretend to be this user, and it'll open up a new shell, basically acting as that user. Another thing to note, if you're not already the super user, this will flat out fail because you don't have root permissions. Normally, you'd have to do sudo su in order to do something like that. So, if you don't specify a username, it'll just become root, and you have to type in the root's password if you're doing it that way. And yeah, if you don't do sudo, you'd have to specify their password. But if you do sudo and you're in the sudoers group and you can actually run sudo commands, it'll let you become the root user with your own password. You don't have to type in the root user's password. And similar here, if you wanted to become the Joe user, you only have to type in your password if you can run sudo. Also, cryptic thing, if you type in the password wrong, sudo will say that you've been reported to some file and who knows where, and, well, where do they go? Kind of topical too. It's coming up. So yeah.
So you could probably reset the password of the user if you're acting as a super user, right?
If you're acting as a super user, you can use the passwd command, and after passwd, just type in their username, and then you can just change the password to whatever you want, as long as you're the root user. If you're not the root user, I don't think that command will work.
No.
Yeah. All right, and also important. There's a dash here after this one, but no dash after these ones. So what the dash does is it sets up the environment to the user that you're trying to sudo up to instead of keeping your environment, which can be important if that user has like special environment variables that need to be set. For example, the root user might have like extra directories in the path so that it can execute extra files or extra binaries. So the dash will let you actually get their environment files so you can get a shell that actually works for certain commands. All right. So trying to run commands that require root permissions as a regular user can be a problem, as we discussed. However, sudo does the sort of thing where you can pretend to be a root user, which is exactly what I was talking about. So for example, if you wanted to install a package, but you're not the root user, then the package installer will fail because you don't have access to the directories that you need to write to in order to install a package, which is usually, for example, this would be varlib, RPM, some sort of database. But if you use sudo to pretend to be the root user, then you can actually run this command and it'll run fine because the process is running as if it is being run by the root user, so it actually has permissions to write to these directories. All right, so some exercises. Create a user on your system for yourself with your preferred username. So brand new user. And yeah, if you need help, raise your hand. So I think, and remember before the command was, what was it? User add, I think, for adding a user. But, or was it add user?
Add user is a specific thing from Debian. It wraps around user add, but it makes it a little bit easier for a few things with some defaults.
And remember, your DoBC user might not have permissions to add a user. Gotta make sure the man page for sudoers actually works too.
pretty sure the man pages for this should
Double check.
Well, he just did.
Well, yeah, he did all that stuff, so. And also, when you create the new user, make sure, see if you can give it sudo powers. So in the etc sudoers file, remember you can specify what users can do what. Should add permissions for your user so you can actually do stuff as that user that you added. Yeah.
Does the password file, passwd, does it just have like my password in there?
No. So by okay. In CentOS, the etc password file does not have any passwords in any way, shape, or form because it has a special flag in the password field that says go to the etc shadow file. And in etc shadow, it'll have your password, but in an encrypted form that you can't decrypt very easily. Yeah, it doesn't store it in plain text.
Yeah, so I was thinking this isn't very secure.
Although it can do that, but don't do it. No.
How does it encrypt it? What is it?
I think it uses the crypt function, which is a part of the Linux kernel. I'm not entirely certain on that.
I believe that's right.
Yeah, and it's specifically meant to be a function that takes a while to run, so that brute force attacks don't happen really fast at all.
And now do you have to try to use it to... Oh no, let's just do that. You gotta give the user My bad. That's great. So, why did you have the slash etc slash you have to do something.
In the sudoers file, it looks like it's adding users who are on the wheel group. No, it's not. It is, but it actually has a separate menu. I see.
Yeah.
User.
All the packages or the commands should be pre-installed for you, and at least the ones you need. Yeah. Because I think. So.
They'll be on any Linux system you get.
Well, yeah, usually. So yeah, user add to add the user. So you edit the etc sudoers file to add a special powers for your user. Change your password to the passwd command. Sue will get you into the account. And then one thing I don't think when you're creating a group, it's just like user add, it's just called group add, so slightly different.
That's how you know.
Oh, wait.
So alright, I'm gonna go power through these if I can. User.
Hey, JJ, how do you switch to your user?
Su command.
Oh.
So
that's
go
right.
back here. Here we are. There's all the Su stuff. And
What
this
if you haven't set a password yet?
Su will work without a password.
Oh, okay, cool.
How do you know what your current
W. Or
ID.
who am I? Sorry.
Who am I or ID?
Sorry, yeah.
So try adding your users.
Who am I is probably better.
Yeah, that'll just tell your username and nothing else. No spaces at all.
It's the command not found.
Who am I is not found?
Oh, I typed it in wrong.
Oh, never mind.
Type command.
Oh. All right, go back to here. So I'm gonna power through these real fast. Permission denied. Oh, I forgot. I already forgot sudo again. It should be user add. Because here, you can see an example. Creates the home directory for your user.
So we did the user add.
Did you forget that? You can make the directory manually. It'll still work.
We tried to change. Oh, do we have to make the directory and then do pass WD in that directory?
Pass WD, you just do pass WD space, then the username. You don't need the directory at all. Hey.
I messed up the sudoers file.
Uh-oh.
So now I can't.
Can you not do anything?
I can't run sudo.
Oh.
We can recreate your container.
Can you really not?
Alright,
run
that
this?
would be.
Yeah, it could be a moment to log into the system. What port number did you use?
Well, here, let me double check to see if it actually is broken. Oh, wow, it's really broken. Okay, yeah. What port number you are and talk to him and he'll get it reset for you.
I'm ready whenever you are.
Oh, I forgot there's a special command. So vi sudo will let you change the etc sudoers file, by the way. Let's see, the other one was change your password. Is it taking too long?
No, I wasn't. I'm stuck in the gym.
Oh. There you go, now I'm on the new user. Yay. Let's see, you get into your account, create a directory called Bootcamp in your home directory. Alright.
You might have that help opportunity here.
So I'm in my home directory.
So I was able to create a new user, give the username I wanted, and now I'm trying to set up its password.
So
Okay, so I want to put in sudo for that.
So when you're adding a group, you don't need to specify a password for a group. When adding a group? Oh, so when you're running sudo, wait, what user are you when you're running sudo?
Well, how are you running sudo?
Take a picture. Otherwise, you have to be root. Unless you know what your password is, just you can reset your password. Since we don't know go back to
And if you need to go through, oh, I got it. You have to, yep. So now you're back. Yeah.
You have to specify your username afterwards. Oh, whoops. Keep going to that one. Yay. It worked. All right.
I'm not sure what that means, so what you want to do is you want to add a line like this for the user who just created it. Yeah, you're not
is that what you're trying to do?
press escape. That gets you out of insert, and then you can press and then now, if you try and
It's where the script changed.
Oh, is the script not
I
working?
don't remember it being like this when I start individual containers.
Wait a minute.
Huh? I know, but
You can't recreate a certain.
I had a script for just starting.
Yeah, I know.
containers,
I remember that.
but it's not. Oh wait. It got changed.
It did. Oh.
Yeah, because the MySQL one is correct. But the yeah, here let me fix it really quick. That's why I was so confused. I was like, why not see it take a second argument?
We might want to start.
Yeah, go ahead and start.
All right. So I'm gonna start moving on. So I think the answer key is right after this. Yeah. So here's a really boiled down version of the answers.
Speak up a little bit.
Oh, sorry. Here's a really here's the answers to the section.
Everybody, he's gonna start continuing.
Sorry. So here's the answer key to the exercises, since I got to start moving on, taking a little bit. So, oh, that's everything at once. Okay, so first off, you got to become the root user in order to do any of these commands, because otherwise it'll sit there saying you don't have permission. And after that, you would add a user, for example, Lance, if you wanted to add a user. Then we would use user add Lance, it would create a user for him, and to edit the etc sudoers command, we have to have this specific layout to make sure Lance can actually execute commands as the root user. It's better to use vi sudo for this, which is what I used when I went through it, but this could also work. So yeah, changing the password for a different user, you can use password command and then just enter in the username afterwards, then you can change their password. And then this way, this specific version of Sue, if you use the dash afterwards, it'll let you get the environment of the user you're becoming, so that you actually get their proper environment variables, which could be useful. And then it said make a directory, so make dir will do that, make a directory for bootcamp. And then creating a group is just like creating a user, except now since we're acting as the Lance user instead of the root user, we have to actually say sudo before it. And since we're in the sudoers file, we said we have to ask a password each time we go to execute a root command. It actually asks you for your password. All right. Further reading, so here's a link if you want to look more into this. Other than that, we're going to move on to the next section. We can just grab a new piece of paper.
Yeah, just grab a new one. That'll be better.
That's all right. Thanks for your help.
Yeah.
All right. So we're going to move on to the file section, which is, well, traditionally what everything in Unix is, which, yeah. And here's some more overview for the section, like what exactly is a file and how do you work with them and what kind of permissions can you set on a file and how they interact with users and groups. So, as I said, everything is Linux is a file. Everything, except for the things that aren't. Linux isn't completely Unix philosophy, but close enough. So, files have a whole bunch of like metadata associated with them, which is data that describes data, in this case, data that describes the file. So they have an owner and a group, which we've already worked with in the last section. They can have permissions, which is like who can do what with them. Like this user can do this with it, this group can do this with it, and everyone else can do these. They have an inode, which is kind of low level, how the file is actually stored on the file system. Because the file name is what you see, but what the operating system sees is an inode, which is like where exactly this file exists in the file system. They also have a size, they have a file name, like I said, and they have all these weird time commands, which actually means the last time the file was accessed, the time the file was, I think, created, and the time the file was modified. And there's also like a change time. I'll get into it later. And then if your file system supports it, and if you've mounted it with the correct options, then it also could include POSIX ACLs, which are access control lists, which are pretty advanced topic, but we don't really need to cover it. Because in Linux, by default, you can only specify one user and one group per file, and anything beyond that you'd have to use ACLs for. Files also have like a spin lock kind of thing. So what this is talking about is if a process opens a file, then other processes can block on opening that file if you open it a certain way. And it'll be like a spin lock where it'll just be sitting there trying to open the file over and over until it can actually get the file. And I think I'm not entirely sure what that is. And yeah, they also have like a sort of link count and read-write link count. So that's like how many different files refer to the same exact data. It's like pointers in C. It's a really similar idea. So here's an example of like a ls command with certain flags passed to it so I can see like verbose data about the file and the inode number of the file. So going through this, we can see the inode number of the file, which is usually some high random number. Well, not random to the file system, but random to us. And we can see the permissions for the file and the file type. So this is the type. Everything after that is the permissions. And then this is like a references count, which is the number of hard links to a file, which I'll get into more a little bit later. The user, the group, the file size, the last time the file was modified, and the file name. So that's everything in there. But then, let's see. And this functionality isn't just limited to the shell. Like, you don't have to only work with files in Bash. This is also, for example, in C, when you open up files, you would, with the idea that everything is a file, including devices that you have plugged into the computer, you could actually open the devices as files inside of a program. For example, here's like a pseudo program that definitely won't work, but it's close enough to what one would look like, so you can get a general idea of how files are handled in C. So you get like a file pointer, which just kind of points to the file, and sort of similar idea to an inode, but more like how the Linux API would know what file to point to without using a file name. And you'd, open the file, and you'd get like a special pointer back from it. And then you can use POSIX commands or Unix commands to write to the file and close the file later, and then you can return something later. All right. So here's also an example of file metadata again. And also another command that can be really interesting is the stat command, which goes into really in-depth what a file is, and this specific file, what is it, everything about it, which includes access time, modified time, and change time, which I haven't really looked into what the difference between modify and change is, but okay. And then the birth time from when the file was created. And I think, so these files are some of these files are really special and are actually way different from normal files you deal with. For example, this file is a character device file, which is a file that characters go into and characters can come out of. For example, a terminal where you type things into and it'll print like text onto a screen. And another example would be a block device, so a hard drive, a solid state device, NVMe drive, or even a network block device if you use stuff like that. And it would use a slightly different file type here. You can see at the beginning it has the B character there, and C there for character device. And these are kind of special because instead of like a references count thing that you would get here normally, which I'll get into more, you actually get a major number and a minor number, which is how the underlying Linux system knows what character device this is or what block device this is. And here's another one. Here's a socket, which is a sort of it's a way for processes to communicate to each other using like sort of like shared memory, but on the disk. And then this is I think this is a FIFO file, like a FIFO pipe, which is really special and I'm not going to go into. And then here's a system link, which is like a link to a file to another file. In Windows, it would be a shortcut, the exact same thing. So if you go to this file, it says, no, I'm not here, go to this file instead. And it would just follow that link and go there. All right. File extensions. In Linux, they're nice to have, totally unnecessary though. Linux can figure out what the file is just by looking at the file itself. So, for example, if you have a bunch of random files in a directory and with no file extensions at all, if you run the file command here, it can still figure out what file it is just by literally reading the file. So if you have a picture of a squirrel and just some random text with no file extensions, if you run the file command, it can still figure out what it is on each file. And let's continue on. And also in Linux, there's hidden files. And hidden files are any file that begins with a dot. So ls, when it's listing files, it'll by default ignore all those files. If you want to see them, you pass the -a flag, and you'll start seeing hidden files here, like this and this. But also you get to see these two files, which we've kind of worked with before. So we've kind of worked with the dot, which is like the current directory is what that means. So each directory has a link inside of it, or a file inside of it that just goes straight to the current directory. And they also have the dot, which is the parent directory of the current directory. So if your file's at like /home/ your username, if you do cd ... then you'll be in /home, which is one file up the hierarchy. And yeah, you can list the hidden files with -a. All right. So here's the metadata from ls-l, and like what everything means. So I'll kind of go through it again really fast. So file type and permissions, the references count for hard links on a file. So I'll explain that now. So each file can have a number of like hard links to, or actually, let's see. How do I explain this better? Each file can be hard linked to another file. So when that happens, the files themselves are completely identical in data. And if you change the data on one file, it'll change the data on the other file as well. But hard links are kind of special where if you have like a bunch of hard links to a file, if you remove a bunch of files, the file data will stay there until the last hard link is gone, which is different from symbolic links, which are saying that this file in particular goes to this other file somewhere else. And if you delete the file that it's pointing to, then all the data is gone. Hard links, if you delete the file that it was linked to, then the file data is still there. And then, yeah, that kind of stuff. So how do you change the metadata of a file? So there's a few commands you can use. Right here we can see chown, which changes the owner of a file, and also can change the group of a file. So if you just say chown and then a username and then a file, it'll change the owner of that file to that username. If you use a colon and then, or wait, if you do a username, colon, and then a group name, it'll change the username and the group name of that file to what you specify there. And if you don't include the username here, then it'll only do the group name. You have to have the colon still. So yeah, here's a few examples of it. Oh, and then a few flags. You can find this in the man pages, but -R is recursively changed all the permissions in this directory so that everything below that directory also gets the same permissions as what you specified the directory to be. Because by default, it only changes the thing you're looking at. Then here's one that specifically does groups, but chown does it too, so yeah. All right. So the read, write, and execute permissions on a file are managed using octal notation, which is kind of weird at first, but then starts to make sense once you actually start using it. So when I go back here, I'll go back here. So here you can actually see the permissions for the user, for the group, and for everyone else all in this line here. So the first part here is the user permissions. So whatever user is specified here has these permissions over here. Whatever after the next three get right here are the permissions for everyone in this group over here, and the three after that are for everyone else on the file system. Yeah. So these are represented, yeah, in this sort of format here, and you can have any combination of read, write, and execute permissions on it. Some of them don't really make sense. Like if you have execute permission on a file, then you probably want to be able to read the file too, but. So yeah, you can see in binary notation what that would look like. So if you did the read the least significant bit would be execute, and then write, and then read. So in binary form, that would be like, yeah, 000 for nothing, 001 for only execute, 010 for only write, and 100 for only read. and then any combination of those for any combination of these. And yeah, these are mapped exactly here. And then an octal is really just, since there's only, 8 possible combinations, then octal maps perfectly to this. So just 0 through 7 in binary form here. All right, and you can change the permissions for each specific user or group using chmod as well. So, or not chmod as well. Chmod is a different command from chown. I don't know, mixed them up. So chmod lets you change the permissions of a file. So this right here says that for each, or for the user and the group of whatever this file is, add the execute permission. So yeah, add the permission to execute this file to its owner and its group. And then chmod here says that everyone else, so others is what that O stands for, take away the right permission for this file. So yeah, that kind of stuff. And you can use octal notation directly here as well, so you don't have to do like these slightly longer characters, I guess. It's just more convenient for some people. It's more compact when printing out. So when you want to execute a file, you have to add the +X permission to it. So execute permission for this file. And let's see here. And this is where it's really important to include this shebang up here. That's what that's called. Because if you don't include that there and it's just like some random text file, Linux has no idea how to execute it. But if you include the shebang, then it'll call that command and then it'll start feeding in everything after that into the command as like a script file. For example, if you wanted to write a bash file, then you can just create a random file with literally any file name. And then as long as you include this shebang, then everything after it will be interpreted as a bash script. And then if you add the execute permission to it, then you don't have to say like bash space run this file. You can just literally type in the file name itself and it'll just run it straight from where you have it, as long as you include like the ./ part, so it actually knows where to find it. All right, types of files. I kind of went through this, but I'll go a little bit more in detail. So the first character of that, the ls-l command, let's see if I can go back to it. So this first character here is the file type, which can be different depending on if it's a, for example, if it's a directory instead of a file. So if it's just nothing here, a minus, then it's a normal file, then you can open it, you can read it, you can write to it, you can execute it, that kind of stuff. The D character means that it's a directory and you can like change directory into it, or you can, yeah, move around with it. The B character means it's a block device, so this is stuff like rotational devices like hard drives, solid state drives, NVMe drives, stuff like that. And L is a symlink or symbolic link, which is saying that this file points to this other file somewhere else on the system. Directories are also files, but the read, write, and execute permissions do different things than they do on files. So R permission allows you to read the contents of a directory so you can actually see what's in it. W permission, write permission, lets you add files to the directory, and the execute permission lets you use the directory at all, because otherwise then it'll just say permission denied every time you try to use anything in it. For example, if you were to take out the execute permission for a directory and you tried to ls it, you would get all sorts of horrible mangled output because ls has no idea what's in that directory. All right. All right, now an exercise. So let's see here. Create an empty file, and then what can you do with the file? So yeah. So yeah, here's the example command for creating a file too here. The touch command, which is just create an empty file at whatever you say. Yeah, also change to group. That. All right, yeah. And don't forget the man pages are your friends. They'll really help you out. All right, I'm gonna start working on it. Here, I'm gonna try something. Is that still readable? Kinda. All right. All right.
Oh, you for the file. So you gotta pick up on it. Well, you want the
All right, so I'm going to move on to the answer key now. So let's see here. So we are create a file. So this will create an empty file, and then you can see all the metadata of the file using ls command, and all you really need is the -l part, but h makes it nicer. And then you can see everything about it. And then the DevOps group we created in the last section. So if you followed that, then you should be able to just run this command, and it'll change the group. As long as you have that section, change the group of the file. If you didn't have the group, then that might have failed, but don't worry about it. And this is also a command you could run to change the group if you wanted to. And then for the all permission file, use touch command to create a new file that way. And then chmod, and then this. So for every, let's see if I can do this, user, group, and everyone else, add the read, write, and execute permissions on the all perms file. Which, if you, after running that command and using the -l flag here to run ls on the file, you see everyone has read, write, execute, and read, write, execute. All right. Oh, what's another way of giving file all permissions? So in chmod, you can also pass in the octal permissions directly, which can be a little bit easier to type in, especially if you're giving all permissions to a file. Yeah. So you'd go back, and instead of running this, you would say chmod 777 and then the file, since 7 is the octal version of read, write, and execute added together, which is the binary number like 111. Here's some further reading if you want to look into it. This is on the webpage. Also, be careful with permissions. Don't chmod 777 everything. If it doesn't work, you'll end up breaking things horribly.
You should never need 777 in production.
Yeah.
If you are, then you're doing it wrong.
All right, we can move on to the next section. Packages, software, and libraries.
Who's doing that one?
I don't know. Someone else. Oh, Jason. All right.
All right.
Go, Jason.
Hi, I'm Jason again. We're going to talk about packages, and mostly packages, so package managers, installing packages, and why we use package managers, and then we're going to have some fun compiling a program or two. So we're going to talk about software and libraries and sort of what those two things are. Then we're going to talk about the general functionality of package managers. I'm going to give some examples of package managers. Specifically, we're looking at Debian and CentOS. And then some more package manager examples for programming languages. And then we're going to try and compile some programs from source to see why we would want package managers instead. So software is basically everything that isn't hardware. So this is all. These are computer instructions that are executed on hardware. You can think of that as software. So this would include your binaries, your scripts, everything from a small script to a huge program like a web browser. That's all software. But then you have libraries, and libraries are collections of code, of shared code, that usually aren't run on their own. Instead, they're integrated into a larger program, and you use the code in that library in your bigger program to do certain things. So for example, in most languages, there's a standard input and output library. So in C++, that would be IOStream. In C, that'd be standard IO.h. So it's just these functions for very common things that are useful in many different applications. You can put that into a library, and when you write programs that pull in these libraries and you compile them, you can either statically link or dynamically link the libraries. And there's a difference and a trade-off between the two. So a statically linked binary basically copies all of the library code into its binary. And then when that binary is run, all that library code is also copied into memory. Whereas with a dynamically linked library, the operating system knows what libraries it needs to link for this binary to work at runtime, and then if that library has not already been linked or has not already been loaded into memory, it will load that library, and then any program that dynamically links that library can use it, can share it. So with a statically linked library, it's more space, it's more memory usage. Dynamically linked library, it's less memory usage, but you might see some slower performance, although that might be negligible. So the purpose of package management is to automatically manage your software. So we want an easy way to install packages, to keep packages up to date, and also to uninstall packages. And using the default package managers for your operating system along with the default repositories usually should get you stable packages, whereas maybe compiling your own programs might not be the best, might not create the best stable system. And so some examples of package managers, which you might not think of as package managers, are the Play Store and the App Store and Steam. And because all these programs are doing is they're downloading binaries and they're installing them onto your device, which may be a phone or your own computer, and you can uninstall them. They keep these programs up to date, just like any other package manager would. And then you have apt and yum. So apt is the package manager for Debian and all the derivatives of Debian, like Ubuntu. And then yum is what's used in Fedora, RHEL, and CentOS. Although Fedora uses a rewrite of yum called DNF. So there are certain things that package managers do, and we really like these things. So the first is install, upgrade, and uninstall packages easily. So you can type in a single command and have the package manager install the package and pull in all of the dependencies. And we like that because if we didn't have the package manager to manage all those dependencies for us, every program we wanted to install, we would also have to find all the packages that package depends on and install those manually. So a package manager really helps us by automating that whole process. And then it also installs packages from a central repository. This, depending on how you look at it, this is a more secure way of installing packages because otherwise you might end up going on the internet to look for the package and you might not be downloading it from a trusted source. Whereas if you're downloading it from the default repositories in your operating system, you can probably trust it because it's been vetted by the OS developers or the people who maintain the repository. Package managers are also useful for searching for information on installed packages and files. So I guess that kind of goes along with that last item. You can look for files if you know a specific file in a package. Like you're looking for a binary called grep, and for some reason there's no package called grep, but you're looking for the grep binary. You can use your package manager to search for a package that will install the grep file into your system. And the reason we can do that is, as I'm going to talk about in a second, a package is really just an archive of files that the package manager copies into a bunch of directories. The other benefit is pre-built binaries. We don't want to have to compile every program we want to install. I keep going to the example of web browsers, but if you've ever had to build Firefox or Chrome, you know the pain. So I'm going to talk about two system package managers. One is Yum, one is apt. They use different formats, so RPM and deb.rpm.deb. They're both just archives with metadata attached. So that metadata might include the package name, the version of the package, also commands to run before and after an install. And then the rest of the archive is just literally the files that are going to be copied into your system to install the package. For RPM packages, you usually want to use Yum, but you can deal directly with RPM packages with the RPM command. So if you download an RPM file, you can install it using RPM, but you might prefer Yum because it automates a lot of things, being able to update packages easily, being able to uninstall them very easily, whereas using RPM, you might have to manually track those things yourself.
Yeah, Yum deals with the package dependencies, while RPM will just say, I don't have the package you need.
Yeah.
I don't know what to do.
Yeah. And really the same thing applies to apt and the dpackage command. Dpackage is the equivalent to RPM. You deal directly with the .ded files. And you might not trust downloading these files directly because you might not know where you're getting them from. So I think you should prefer the package manager. There's some comparisons between Yum and apt. The repositories both kind of work in the same way. You can host them on an HTTP web server or an FTP server, and they pull those files directly in. So it's like any website. And then apt has this really nice feature, purge, if you've ever used it, apt purge, which can remove all files, which is really nice when you're trying to actually uninstall a program. I don't think Yum has the equivalent. And I've also found that apt is a bit faster in resolving dependencies than Yum. So here are some package managers for programming languages. I hope to God you never have to use npm. I don't like npm. It's a mess. Ruby Gems is pretty cool. Yeah. So some other package managers that you'll deal with depending on what operating system you use. So Portage is the operating system or the package manager for Gentoo. I don't have much experience with it. Yaourt is a package manager for the Arch user repository. It's not an official package manager. Instead, it's a package manager that was built to deal with this community repository. So the Arch user repository is a repository of community submitted packages, and these are for packages that the Arch developers don't want in their default repositories for some reason. And you can download these. You can edit the install scripts, and you want to look at the install scripts because these are created by anybody and uploaded by anybody. So you want to check that they're actually doing what they say they are. And then Nix is really interesting. It's called a fully functional package manager. It's really nice in that when you upgrade packages with Nix, you can unupgrade it. So you can undo upgrades because it represents packages as these pure functions, and it's a math thing that I'm not too like knowledgeable about, but it's a really nice package manager that helps, that can, if you screw something up, you can roll back really easily. Homebrew is for OS X. I don't think many people are using it. And then I have no idea what chocolate is. So the general steps for installing a package from source is you download a zip file of all the code files, or you might clone a Git repository, and then usually there's some kind of make file, or where you run configure. It creates some kind of make file. You give it options for what you want to be included in the program. So there might be options to add certain libraries or take away certain libraries, which will affect the functionality of the compiled binary. And then you actually compile it and then install it. So this process it can be difficult, because depending on how complicated the program is, if it pulls in a lot of dependencies, you're going to have to manage those dependencies yourself. You're either going to have to install them yourself using a package manager, or you might even have to compile those from source. So it's really complicated and error prone. I'm not sure. You would use this if the default packages in your operating system's repository weren't compiled with the options that you want. So generally that's not the case. And we have an exercise where you have to compile a program called SL.
And hopefully this doesn't crash our Docker server. And use past we've had that problem.
Do I have to do this?
Yeah, just wait until you can split it or wait, have you used?
Not in a long time.
Just keep it up there like that for now.
Oh no. What did I do? Mohammed, are you doing this?
Yeah, I will. I need to install GCC and make.
Okay. The Docker container is on send us, so we would need to use the YUM package to install it. So that would be the packages you need are listed up there. So that's horrible. Oh wait. Oh, we already installed it. So we just need to make sure they're installed, because if you try to so this is a CentOS container, the package manager you're using.
Yeah, we don't. You want to do YUM install first.
Yeah, he's going to detail that. But YUM is pretty simple. That's all. YUM stays installed. Yes. Yeah. Oh, I think literally YUM space install. And it'll figure out the package.
I let the other two guys know that we're here. I know what's behind it. The industry panel.
Yeah.
I think I can remember. There's
The only thing is another exercise that they're trying to compile correct.
So yeah, you see that runs root user before it. So you press the command back. So you wait here.
That's for your yeah, because it's less than 4 hours.
Did you do it? Did you do it? Was it that quick? Was it that quick?
Yeah.
So the DoBC
No.
can do sudo.
I just had to install some packages.
So you're just doing the command again, sudo again. It's not going to be there because you did it as an
I think it's going to work.
everything. So this is okay. So you can type so the 4 you specify is what it's installing plus the dependencies of the because it sorts the dependencies for you. So you don't go hunt down all the it'll just download everything.
Will help people.
It's doing it for the programming there. So the second step says clone that you can get to download the source code for that project. That project we're going to compile it on. That's yeah, we're going to I think what we might do is we'll go with the web one and maybe after I don't know how so I mean yeah, this is how you would be installing something but for I'm sure yeah. When you accidentally that's all
I've done that before on my work. Oh, okay. I get it. I get it.
I think it should already be on there.
Oh, it is.
Yeah. All those ones are probably already on there.
Great. What software are you looking
Every way to learn, every time I try to teach it.
So,
There's some good tutorials like just how to like clone a repo and stuff, like have them set up.
I understand. Everyone's all it's on that is when you started a master brand new Python, fix it, add it back,
Yeah.
work on it, add more,
Yeah.
add it back, do it a couple times.
Yeah.
What if, like, the second through
So
the last
you can actually
or
see
the
if it's in
the thing that you added in the very beginning?
Very
it's but you can do
like a brand?
Yeah.
Yes, you probably want to branch instead of forking. It's like forking is like well, you can like that's the good thing is like you make branches and then what's usually good to do is have like a master branch and like a developer branch, and then those two are the same. And you develop everything as a developer branch. Once that works, then you can merge it into a master branch. So that way your master branch is always only good stuff, and that keeps it so that your master branch is always like right, and your dev branch can be kind of wrong.
Yeah, it does actually.
And then you branch off of dev, so you make those
so if you want to install it, you can
push those into dev, and then you make pull requests.
container since you don't have the GUIs.
So what if you're doing that and the master is the one that works?
Yeah. So
Yeah.
And you, let's say that
You might as well go ahead and start doing it yourself.
Oh no. I didn't think I was gonna have to do this. Are the dependencies installed?
No.
No.
I believe so, yeah.
Get GCC.
Just don't make GC.
Oh yeah, you can start making all that first.
So after
you could.
Where's the terminal?
It's in window 2.
That's tough because you probably have to.
That's not your
Or is
So
it?
you're in. Go list.
Am Go back over to the show. Okay, yeah.
Like
And then
that
it's,
kind of stuff is tough
yeah.
because that's more
Oh,
so like
okay.
if the code's wrong,
That makes sense.
Do you install Git?
CC.
I'm not exactly sure. Yeah, exactly what you're trying to ask. And all I'm saying is that because this isn't a container, I don't really think it's logically. It's just kind of there's a lot of planning that goes into it, I guess. And I don't know exactly. Sorry. So in this case, what you're logged into right now is a container, which is like it's almost like a Linux operating system, except it's a lot of the functionality is stripped out. There's the main subset of Linux. So this is so we can have like 100 different, basically, versions of Linux running on one container, so that everyone can.
Am I just running make? Oh, that is very fast.
Well, it's a very small application.
Okay, so yeah, if you have a real version, then you could install that. Since the version actually open up so you would need to install a version software. Yeah, Linux inside of the Vagrant might be really helpful.
Oh wait, no, I don't need to do that.
It's like a couple options. It's like one of the ones that's like moves around.
Yay.
Or it's like a little small train. It's not like that. It's so big. It's good because you can like put it in your pad. If you type like if you like type that LS but you type SL, it's gonna like run the train.
Hey, does anybody need any help doing that? Whatever just happened on the screen? Apparently not.
Is it good? It's probably just like a
Everything you want to do. So
it's probably just like a lot of like echo commands that are spread out the screen. Because it like runs its own like programs. I don't know exactly what it is. It's kind of funny though. It'd be kind of hard to say. Oh, like how to print it out. Yeah, it's hard to. I always
All right. So we're going to try and do our industry panel online. Hopefully my folks will get online soon. So I'm going to stop the stream we have, and I'm going to start a new stream. Hopefully it all works. So.
There's no good way to do it, honestly.